everyone. Welcome back to SQL Server Virtual Conference, Day 1, Part 2.
Yes, welcome back. Things are going well. Looks like people are having fun. Our speakers did a great job. Learn a lot. I learn a lot. What do you think, Simon?
I've been enjoying a lot. I won't say learning a lot because most of it goes over my head, but I just love the last session that Buck had. People really enjoyed it. And what I really love about Buck is that he keeps the session very interactive, and so is what I'm expecting from our next speaker, who is Erin.
All right, let's invite our next speaker and kick off this second half. Welcome, everybody, and let's enjoy.
Yeah, so Erin's going to talk about understanding statistics in SQL Server, which is very, very important. And quick fact, Erin has over 19 years of experience in this field. She's a Microsoft Data Platform MVP, and she lives in Ohio. So let's go and invite our next speaker, Erin.
Hey, Erin, how are you?
Hi. I am fabulous after that introduction. I've never had anything like that. It was just so cool and fun. Thank you.
Well, that's all Stephen is doing all the work behind the scene without even letting you know. By the way, that video is available to you if you want to use it somewhere else.
I think I need it. I need like a walk-in song, right? Or what do they call it? A walk-up song or whatever. Love it. Thank you.
We'll make sure we give it to you in the follow-up email. So yeah, but there's a big team behind me, who just work with me. So that's great. So we won't take much of your time, Erin. We already know we are at 3 minutes more. So I'll just go ahead and pull up your screen, and next 45 minutes is all yours.
All right, awesome. Thank you. And thanks again to you all for having me. So we're going to talk about statistics in SQL Server, and this is one of my favorite topics. So I'm going to zip through some of my beginning slides here because I want to get to talking about the real content. This is all the information about me, and really the most important thing on here is my email address, erin@sqlskills.com. If you have a question that doesn't get answered today, feel free to send me an email. I'm happy to talk about statistics at any point. The SQL Skills team, I have our names up here on the screen because sometimes I talk about other members of the team and I want you to know that they're real people. So Paul and Kimberly are the owners. Tim, Jonathan, and myself are consultants in the team. We offer training at conferences. We also do our own training immersion events that are going to be online this year. And we do provide consulting as well. So if you're interested in learning more about SQL Skills, please hit our website. I've got multiple links up here, but sqlskills.com is where you want to go. And the scripts, the slides for today, they are going to be available on GitHub. And I'm just going to bring this up for a second. And actually what I should really do is take this and throw this into the chat somewhere. But I don't know how to do that. So hopefully if you just search GitHub and my name, Erin Stellato, you'll see this SQL Server Statistics repository, and you can grab everything from today there. Please enter any questions you have in the comments section. I'm not going to read the abstract. I'm hoping that you all have an idea of what we're going to talk about here with regard to statistics and their importance when we talk about them as it relates to SQL Server. So we're going to do a review, and we're going to look at how we find statistics in SQL Server. And then we'll talk about what happens when they go bad and how that can affect performance. And we will also then talk about how we update them, because that is really one of the most critical things. So the reason that we care so much about them, the reason that I have done, I don't know, well over 100, I don't know if hundreds sessions on statistics, is because they are absolutely essential when we talk about performance. And a statistic in SQL Server is information about the distribution of data in a column or a set of columns in a table or a view. So if you, let's say you have a column which is customer ID. And you want to understand not just maybe how many, it's not like how many different customer IDs we have, but customer IDs as it relates to the number of orders that we have in the orders table. Our statistics are how many customer IDs do we have for all these different orders, right? What does that look like? And it's important to have these stats, to have this information available for the optimizer, because that determines what it's going to do, what kind of plan it's going to generate. And it uses these estimates from stats to figure out how many rows are going to be returned, which is also called cardinality. So you may hear the terms cardinality estimator, right? Which is basically, we're going to use statistics to figure out how much data is going to come back. So pictorially or visually, if you want to think about how we look at this, you submit a query to SQL Server, and it then goes to the query optimizer, which uses statistics to say, what is the object? What is that we're going to access? Are we accessing a table? Are we accessing an index? Are we doing a seek or scan of that index? How are we joining to other tables? How much memory do we need? So there's a lot of information that basically comes from, or a lot of decisions that are made based upon these statistics. And then from all of that information, the optimizer puts together a plan, which then gets executed. So one of the most important things is to understand that stats are going to influence the performance of your queries. Now, when we talk about stats, there's a lot of options that are relevant here. So I want to take a moment to highlight them. The first is auto create statistics. And this option is enabled by default whenever you create a new user database. I recommend you leave it enabled. Auto update statistics is also enabled by default when you create a new database. And I recommend you also leave that enabled. There's a third option here, which is auto update statistics asynchronously. This, one of my good friends, Glenn Berry, definitely recommends that you update this, or that you enable this option. It is not enabled by default. And there's something I want you to understand about that before you decide if you're going to or not. So I'm going to come back to that later on. And then there's also this option of auto create incremental statistics, which is going to be relevant for you if you are using partitioning. If you're not using partitioning, don't worry about it at all. Now, these stats, how are they created? There's multiple ways that they can come into existence within SQL Server. The first is automatically. Every time you create an index, every time you create a filtered index, every time you create an indexed view, you will have a statistic created. So if you look at this syntax here, create non-clustered index on my sales orders table on the order date column. So if I create this index, what happens is when I then look at sys.stats, I also have a statistic. And notice, what's really important to notice here is that the name of the statistic is the same as the name of the index. So the index was named NCI _orders _order date. The statistic here has the same name, but they are two different entities in SQL Server. That's really important to understand. Now, we also get statistics created on individual columns within SQL Server. So if you query a column or you join on it, you get a statistic, assuming, there's a little asterisk there, assuming that it doesn't already exist because it's the leading column in an index. So for example, let me come back here for 1 second. In this example here, we created an index on order date. So if I have another query that queries on order date or joins on it, it's not going to create another statistic. There's already one here. But in the case where I have a query against that orders table where I say expected delivery date equals a value, if there's not already a column statistic there, that will go ahead and SQL Server will go ahead and create that statistic, that column level statistic for me. Now you'll notice the naming here is way different, right? The column is named expected delivery date, and we have a statistic name that starts with _WA _sys and then a bunch of numbers and letters. That's because it's auto created and it's column level. So that's a naming convention that gets followed. So I'll take a note here that's to say, if you ever manually create statistics, don't follow that naming convention. Use your own, right? Because this is how you know it's an automatically created column level statistic. So this is the case where this column is in the predicate. When I join on the column, so here we're joining to orders based on back order ID. And here I've joined on that column. I don't have a statistic for it. And so SQL Server says, I'm going to create a statistic here on this back order ID column. So again, automatically created for indexes, filtered indexes, indexed views, automatically created on columns when we query those or we join on those. Now we can also create stats manually. So these can be created on one column, on an individual column. They can be created on multiple columns. And you can also create filtered statistics for a column. And there's a question here from Paul that says, should we ever create multi-column stats without using an index? That's a big, it depends, Paul. I would really want to talk a little bit more about the query that you're trying to troubleshoot or improve performance for before I just said yes. Because yes, there are times when you would want to create a multi-column statistic without the index. And there are other times where I would say, I really want you to create the index here. So that's a little bit bigger conversation than what's in this slide. Now, how do we look at stats once they've been created, whether they're created automatically or whether we've created them manually? The easiest things to do is use sys.stats, and that's how we can view all stats for a table. The stats date function tells us when a statistic was updated, which can be really important when we're troubleshooting. And then my favorite thing, honestly, if I ever have to have a favorite DBCC command, it's this one. It's DBCC show statistics. And this gives us output in 3 sets. It gives us a header, it gives us a density vector, and then it gives us a histogram. And if you can understand this, and we're going to take a look at it, then it goes a long way to understanding sometimes what the optimizer is doing. We also have DMDB stats properties, and we have DMDB stats histogram. These are DMVs that were added in more recent. DMD stats properties was added in 2012. Histogram, I think that was added in 2016. We don't have a DMV specifically for the density vector, but these are easier to use programmatically compared to show statistics. I admit I grew up on show stats. That's what I tend to use. So I'm a very visual person. I like to look at what's going on in SQL Server. So we are going to switch over to a demo here so that we can take a look at how we find statistics in SQL Server. So I'm using a copy of the Wide World Importers database that I've named slightly differently. And first I want to show you 2 things. One is SP Help Index, and the other is the SQL Skills version of that. So SP Help Index is available by default in SQL Server. The SQL Skills version was written by Kimberly, and it just gives you a little bit more information. So I start with this because I want you to see what indexes exist, understanding that we're going to have then statistics on each of these columns. And if we look down here, we just get a little bit more information in addition to what we see above. Notably, we get included columns and the filter definition, which can be really helpful when you're doing index strategies. Now, we can also, as I said, use sys.stats, which this gives us all of the statistics that exist. So you'll see that we have 5 stats that basically mirror the indexes that we have. And then we have 3 column level statistics that exist here in this orders table. And we're really going to focus on this index, which is on customer ID. And if we look at the statistics for this, just specifically for this statistic, we are going to get this 3-part output that I mentioned. We have the header up here. And the thing about the header, and I'm going to zoom in here so that we can see this a little bit closer, is that we see when the statistic was last updated, pretty recently, we see how many rows were in the table at the time the statistic was updated. So this doesn't update continuously, right? That row count is valid as of when stats were updated. This tells us how many rows were sampled. Basically, how many rows did it go check to figure out what the distribution looked like. And we've got steps and density here. And then in the middle, we have what's called our density vector. So this helps us understand how unique the customer ID is. And then at the bottom here, we have what we call the histogram. And each of these entries under range high key, each of these are different customer IDs. And then this EQ rows says, okay, for those customer IDs, how many rows equal that? So for customer ID 1, we have 5,346 rows. For customer ID 42, we have 5,295 rows. And you'll notice there's some gaps in here, and there's only 200 steps in the histogram, plus another for a null value. But if we have more than 200 customer IDs, which we do, we can't have a step in the histogram for every one. So we end up with some gaps. And to get estimates as to how many rows are in between that, we use this average range rows. So you'll notice that we have an entry for 42, we have an entry for 45. So if we queried for 43 or for 44, it's going to use this average range rows value to estimate how many rows exist for that customer ID. So I'm going to show you this in action. And just for reference, I have the DMDB stats properties and the DMDB stats histogram DMVs there. So you can go ahead and take a look at those if you're interested. But this is our query, and we're going to enable our execution plan. And we'll go ahead and run this. And this runs pretty quickly, right? But what I want to pay attention to is how we figure out that cardinality estimate that SQL Server has, right? Where does that come from? And if we look here in this pop-up for this index seek here, which this is where we're going against that non-clustered index, and you'll see that it estimates the number of rows we're going to return is 5,295. And that matches actually how many rows it returns. So that's a really good estimate, right? And if we double check, right, it was 5,295. If we double check here back in the statistic for 42, sure enough, we see that that estimate is correct. So this is a case where what SQL Server thought was actually correct. So our statistics are accurate, they're up to date. Now, as I said, not every value can fit into the histogram. So what happens if we query for a customer ID of 52, which is not in the histogram? And so we'll look here at this plan, and we'll come in and we'll see that in this case, for the value of 52, it estimates 5,404 rows. But the actual was 5,437. So it's pretty close, right? It's not too far off. I wouldn't think that that's astronomically different. And again, if we check back here and we look at our histogram and we see, okay, for 52, there's no 52, but that estimate was 5,404, right? And that's because, let me just get this all straight. 52 falls between the value of 50 and 55. And so it says, okay, on average, the number of rows for each value between 50 and 55 is 5,404. So that's where it gets that estimate. This is all well and good when we're doing literal values, right? But what happens when I use a variable? So here I'm going to declare customer ID, and then I'm going to set it to a value of 42, which we know is in the histogram, and then run this query. And now when we look at our plan and we look at our estimate, this is a little bit different than what we saw before, right? Now we have this value of 5,845.25. So I don't remember seeing any kind of decimal numbers in our histogram. And here's what happens. The value for customer ID isn't known when it does optimization, so it uses the density vector. Remember I mentioned the density vector briefly? And I said that tells how unique it is. So here's the density vector in the middle of the DBCC show statistics output. And you'll see this value is 0.001. So again, this is an estimate, or this is a calculation that it does to say, on average, how many rows return for a customer, any given customer ID. And you can do the math So we can take that density vector and we can multiply it times the number of rows in the table. And when we do that, we can see that there's that 584.25, right? That estimate that it comes up with. So that's great, okay, if I have an equality, but what happens if I come into a less than scenario, right? So give me the information from this table, from the orders table, where my customer ID is less than some variable value that I've set. And when this one comes back, this returns tons of rows. You see it changes the plan, actually. And in this case, right, estimated number of rows, we're in like 1.1 million here, right? This is way higher than the 5,000 that we were in before. And so the estimate in this case is it's taking the number of rows in the table times 30%. So it just estimates that it's going to have 30% of the rows, 1.1 million return. So now you can see that it uses the histogram to get information about how many rows it's going to return. And all we've done so far is just query with literal values. And by a literal value, well, we did a little variables here, but with a literal value, right, where we've said customer ID equals 52, customer ID equals 42. Now, maybe some of you have a lot of ad hoc queries that have literal values like this, but I'm going to guess that some of you also have stored procedures. And Alvaro says, where is that 30% coming from? That's just part of the heuristics that SQL Server uses. So you don't get to mess with that. You don't get to change it. That's the way that it is. So I'm going to guess that some of you have stored procedures. And we're going to create one here. Very simple. We're using that same query that we were just using, but we're going to put that into a procedure. So customer ID is what we're passing in, and we're going to run this exact same query before for a given customer ID. So let's go ahead and create that stored procedure. And then we're going to set statistics IO and time on. And I'm going to run this stored procedure with our value of 42. So we know this returns about 5,000 rows, right? 5,295. And if I look at my messages here, I can see that we have about 16,000 reads. And if I look at my plan, what's important here to note now is we're going to talk a little bit about the shape of the plan, what the plan looks like because of what the optimizer decided to do based on statistics. It decided to do an index seek. It said, I'm going to use that non-clustered index that we looked at before, that FK sales customer ID. I'm going to go seek that index, and I'm going to pull the customer IDs that have a value of 42. But it also needs order date, and order date isn't in this index. And so it has to go do this key lookup over here. And where we only have a few thousand rows, that's not so bad, right? It's not great. You can see I have a missing index recommendation. We're going to ignore that for now. But a key lookup for a few thousand rows isn't awful. Now let's see what happens when we do this for a value of 823. Now, you'll notice here down in the bottom right, this query returned 22,000 rows. So we just quadrupled the amount of data that we're returning. And it executed pretty quickly. But notice now that we're up to 67,000 reads. We were at 16,000. Now we're up to 67,000. We've tripled here, right? And if we look at our plan, you can see things start to look a little strange, right? The estimated number is 5,295, and the number of rows is way higher, 22,000. So what's important to remember here is that when we execute a stored procedure, the initial value that it uses to compile that is used to determine the plan, and then that plan gets cached in the procedure, right? In the procedure cache or the plan cache. So that's going to be reused regardless of what value I pass in. So if I run this same thing with a value of 422, this is going to take, it still runs pretty fast. This is, 120,000 rows are coming back. But if we look now at the messages, this is 366,000 reads that it's doing instead of 16,000 or 67,000. Right now we're up in the 300,000 range. And it still runs really fast, but this is not efficient. We still have the same plan because that's the plan that's cached. And it's going to continue to use that until something changes. And in our case, we're going to do something horrible. Something as a reminder, right? I'm just going to throw this in here just as a friendly reminder, right? Not for production. We're going to do a DBCC free proc cache, which basically means get rid of all of the plans that are in cache. So we do that, and we're going to run this procedure again, which now means that it's going to go through and it's going to create the plan based upon the estimates that it gets for the customer ID of 422. So it returns 100,000 rows. And if we look at the plan, you'll see that this is a different plan, right? Rather than that nested loop that had the index seek with the key lookup, now we get a clustered index scan. And Jan, I don't know if it's Jan or Jan, so I apologize if I don't have that correct. But yes, this is a parameter sniffing issue or parameter sensitivity. You'll hear all of that, all of those terms: parameter sniffing, parameter sensitivity, PSP, right? So now with this value of 422, if we look at our estimates here, right, we get 119,000 rows. And it actually, that's what it returns, right? But it does a clustered index scan. And you might think, well, hang on, aren't seeks great? Isn't that what we want? Well, if we look at the amount of IO that it did, right, 35,000 versus 366,000. So this is a case where customer ID is a value that I would say it has a skewed distribution. Now, what do I mean by a skewed distribution? Let me show you. Let me go back to the slides and let me show you a little bit what I mean about distribution, right? If you think about the histogram, you see in the middle here, this 422, right? And there's a bunch of other values across the bottom. And we have the kind of this nice flat bit. And then we have these little spikes in there. So that is my skew, right? If I had a nice flat line all the way across for this, then that would tell me that my data is pretty evenly distributed. I wouldn't have a parameter sensitive issue. But if I look at this a slightly different way, if I order this data based by the count, 422 is all the way over there on the left side of the screen, you can see that I have a few big values and then it really evens out. So this becomes a problem in a parameterized scenario, like with the stored procedure, because the plan that gets into cache for most of these values is pretty good, but every so often it might not be so great. Okay, now how do we manage statistics? Well, you can let SQL Server do it, or you can set up scheduled jobs. And these are important. This is what I recommend. I'm going to talk about what SQL Server does, but I'm going to step onto my soapbox for a second and tell you that I really want you to manually manage statistics by creating jobs that run on a regular basis. If any of you are familiar with Ola Hallengren's maintenance scripts, Ola has a method to do this. I've written some blog posts that I have links to at the end that talk about how you can just manage stats with his scripts, not even worried about indexing, reorgs, and rebuilds, but stats alone, which I think are absolutely critical. So I could spend an hour talking just about that. But what I want you to understand is that automatic updates are going to occur even if you are manually managing stats. So you're going to make a best attempt with managing stats manually, but automatic updates are still going to occur if you have that automatic update option enabled, which you do by default. Now, again, this can be asynchronous, which means that when SQL Server detects that it needs to update stats, rather than doing it right away, it will wait until whatever query you were going to run finishes, and then it will update them. So the benefit is that whatever query you were going to run doesn't wait for stats to be updated before it executes. It just goes ahead and executes. And then stats get updated later on. The drawback here is that maybe that plan that it's going to use isn't ideal, and I want it to get stats updated and then get a better plan. So there's pros and cons to both options. Again, in your environment, you may want to try one. And if you don't notice any problems, if things seem great, then that's probably the option for you. But by default, asynchronous updates are off. Manually, again, part of your regular maintenance that you should be doing. And there's a couple options that are really useful when we talk about updating stats. One of them is no recompute, which means if the auto update kicks in, don't update stats for a particular statistic. This isn't something that you enable across the board. This is something that you, it's a calculated strike when you apply that to a statistic. And then there's also an option of persist sample percent, which by default, when an automatic update occurs, it uses a default sample, which is about 10% or less. And if I want a statistic to always be updated, let's say with a full scan, because I have a skewed data distribution, I can choose to persist the sample percent for that so that no matter when it updates, it always updates with a full scan. So these automatic updates are going to occur if I have auto update enabled when a certain number of modifications occur. And this is based on a threshold. And that threshold depends on what version and compat mode you're running. So the old threshold would be when 20% plus 500 rows had changed, 20% of the data plus 500 rows. That new threshold is the square root of 1,000 times the number of rows. So the new threshold is the default behavior in 2016 and higher if you have a compat mode of 130 or higher. In earlier versions, all the way back to 2008 R2 Service Pack 1, you can get that threshold with trace flag 2371. And what this looks like in terms of numbers is that it makes the threshold a lot smaller. Because when we talk about a table with, let's say, 100 million rows, 20% of that is 20 million rows. You could be waiting a long time for stats to update. So for as much as I want you to manage stats, there are places that don't. And so for some of those environments, those stats were getting horrifically out of date. And so this lower threshold is designed to get those stats updated on a more regular basis. So I want to show what happens when we don't update those, and also what happens with our plans. So I've got another, this is my out of date stats script. So I'm going to mess up statistics on purpose. And I did a great thing here. I had this demo where I changed my connection parameter and it keeps going back here. So let's get this sorted out here. And while this runs, this only takes a minute or two to run. It looks like, let's see, there was another question. Are auto-created stats updated when you rebuild your indexes? It's a great question. When you rebuild an index, if I rebuild all the indexes for a table, the statistics for those indexes get updated, but the statistics for the column level statistics do not. Whether those column level stats are automatically or manually created, by default, if you use Ola's script, he has an option to update all statistics, which means your index stats and your column level stats. But if you just did an alter index rebuild, it doesn't hit any column stats on a table. Great question. All right, so I've prepped this. And we're going to go back to my Wide World Importers B database. And we're going to just double check our statistics for this orders table. So we just restored this database. Times become really important here. 154, 3.6 million rows in the table. This sample is 171,000 rows. So this is a default sample, 10% or less, right? Not a full scan. And I'm going to turn on statistics.io, and we're going to run this query, a little bit more complicated than we were looking at before, with a few different customer ID values. So we'll go ahead and run these. Again, that 422 is in there, which we know is skewed, right? So let's go ahead and run each of these, and we'll take a look at our statistics output here. So we can see that we're getting 92,000 reads. We're getting 277,000 reads. We're getting 366,000 5,000 reads. And our durations are going up a little bit here too, right? 1.7 seconds, 1.7, 3.4. So what's going on here? Let's grab this. I have a note to myself that I want to grab that info. So I have to listen to my own directions, right, that I give myself because I wanted it for a reason. And again, let's just double check here what we have for stats, right? Okay, so we're at 3.6 million rows, 171,000 sampled. Now we're going to, actually what I want to do here, I want to check one other thing. If 422, 823, 42. Let's look at what we have here. 42, right? Somewhere around the 5,000 range. 422, right? This is 8,000. So this is different than what we had in the table before. Okay. Now, we're going to mess with the data. We are going to add a lot of data to customer ID 422. And let me tell you, I've turned off auto update statistics. Oh, I hate it when my other demos creep in and mess up this one. So I turned off auto update statistics for this. Oh, it changed my context. Love it. And I'm going to change a significant amount of data in this table. We're going to set all of these to a customer ID of 422. So now we've got over 500,000 rows in this table. And I'm going to run this time with the live query stats. We'll kick this off, and you can see that it's pushing this through 3 nested loops. And it's going to take several seconds for these 500,000 rows, 1.3 million rows in the end to come through. Right? I love looking at this. I'll run this again. Right? So we can see, I'm going to zoom in here, right? It's estimating just a few thousand rows are going to come out here. And it ends up being hundreds of thousands. So my estimates are way off. This plan is really inefficient for the value of 422. So let's turn on auto update statistics and make sure that we're in the context of that database. And I'm going to turn off my live query stats because at this point, I'm going to make these things run a little bit faster. And now we're going to run this for customer ID 422. And this still takes a little bit of time because we're bringing back over 1 million rows, right, out of a 3 million row table. So it's not necessarily that much faster, but this is a change in the plan. Before we had 3 nested loops going on, and now we've got just this one hash match. And now we have a clustered index scan here, and our estimate in terms of how much data is going to be returned is way above that 2,600 number that we saw before. So let's look at statistics. Haley, I want to know why you're holding your breath. Here, if we look at statistics and I look at a value of 422, right? This has been updated. If I look up here, right, we were at 150 something earlier, now we're at 159. So when I turned on auto update stats, because I had modified so much data, when I ran that query, it said, oh, okay, I see that stats have changed and that I need to go, or I see that data has changed and I need to go and update stats. And after it updated stats, then it generates a new plan based on that value of 422. So I want to understand how stats affect performance now here at my procedure level. So we're going to create our stored procedure, which is just like the query we've been using, right? Now we're just putting it into a procedure, and we're going to run this 10 times. And we'll check out the plan. This plan goes back to the nested loop plan, right? So this, again, is a parameter-sensitive query. With 422, we ended up getting a hash match. With something lower than that, in this case, where it's estimating about 5,800 rows, we're getting those nested loops, okay? So 2 different plans occurring here. We've run that 10 times. And if we look at the plan cache, we can see here that this has executed 10 times. We've got 1 plan, and the query plan is what we were just looking at here with those nested loops across. Excellent. Now, and I have auto update enabled, right? Now let's just take a look here at modifications, right? So this is a pretty slick view. I like this a lot because this tells me how much churn there is, how much data changes in my table. And right here, I don't have any modifications because I just updated stats, right? And we haven't done anything. So let's go ahead and update a few 60-some thousand rows so that we cross that threshold of when an automatic update's going to kick in. And let's verify that we changed that data. We did, right? We changed about 70,000 rows. So that exceeds this 60,000 threshold with that new stats update threshold. And then we're going to run this again. And if we look at the plan, this plan looks exactly the same, right? It has the same shape that we had before. We've got these nested loops going on in here. So how do I know here if anything actually changed? Well, first of all, let's see if stats updated. They did. Remember, they last updated at 159, and now it's 202. And the rows sampled has changed. We did have a full scan before, and now we're down to just a default 171,000. How do we know that this is recompiled? This is a nice little trick here. When we look in the plan cache for this particular plan, you can see this plan generation num bumped up to 2, and our execution count reset. So even though it's the same plan, it recompiled it. So it drops the execution count, it gets rid of the info, and the plan generation num increases by a value of 1. Last scenario, we're going to recompile this procedure on purpose. And we're going to run it with a value of 414 for my customer ID. And let's see what plan we get here. We get that nested loop plan. And if we check this out, right, we can see that it's estimating 4,939 rows. So when we're down in that flat part, down on that 5,000 row range, we're getting this nested loop scenario. We're going to go ahead and modify some more data again because data changes in your system, right? Throughout the day, things change. Let's confirm that we've exceeded our thresholds for change. We have for a couple stats. New threshold is 85,000. We've exceeded it in some cases. So let's see what happens when we run with a different parameter. We switched plans, right? So enough data had changed that when I went and ran this again, it went and updated stats, and we got a different plan in here. And this happens, okay, great. We can run it a whole bunch of times, and every single time now it's running this with these values that end up returning like 5,000 rows, but it ends up doing this clustered index scan and this hash match, which is inefficient for this. Again, parameter sensitive type of scenario. And if we look here in the cache, right, we can see that this is that recompiled. And what happens here is when a plan changes for whatever reason, because a bunch of data came into the system and stats automatically updated, one of the things that folks tend to do is they tend to look at stats, which is great, but there's three things really that you got to pay attention to. You need to look to see when they were last updated. You need to understand what the sample rate was, and you also need to understand if there have been modifications. So at this point, we have a plan and cache that's a clustered index scan, which we don't love. And if we don't understand that there was a recompile, we might look at this and we might say, oh, you know what? I think we need to update stats here. I think that's what we need to do. And that's often a sledgehammer approach. And people sometimes think that it's updating stats which has fixed the issue. And in some cases it is. But some cases what happens is that updating stats causes a recompile. And the recompile means that the next time I go and execute this with this value of 414, I'm going to get a new plan. I'm going to get a better plan and things seem to be good. But in this case, I didn't get a better plan. And this is, then people are really scratching their head and they're going, what happened here? What's wrong? Here's the thing. If you update statistics and no data has changed, right? We had row modifications of 0. Then stats are going to get updated, and they've been updated here, right? We can see that we updated with a full scan, and sure enough, that's what it did. But even though it updated stats, because no data had changed, it didn't recompile the plan. And this is an interesting thing to understand about stats, and something that I want you to think about when you're troubleshooting and looking at plans with poor performance and thinking that maybe I have a stats problem. Maybe you do. But I don't want you to assume that just because you update stats, you're always going to get a different plan. You want to look to see when stats were last updated. You want to understand what the sample rate was. And you also want to understand if you've had row modifications occur. So this is something that catches a lot of people out. And I have a note in here about it. So in SQL Server 2012 and higher, which I'm hoping a lot of you are on, right? When stats are updated, if no data's changed, the plans aren't going to be invalidated. So you won't get recompiles. Prior to that, the behavior was a little bit different. If you updated stats and you had updated auto update enabled, the plans were invalidated. But if you had auto update off for some reason, then the plans weren't invalidated. So understand that the estimates that you see in the plans are not always correct. I created a contrived scenario where the first case is true. Stats hadn't been updated recently. And updating stats did address our issue. Sometimes your estimates are off because of that skew, the uneven distribution of data, or because the sample rate is too low and it doesn't have a good capture of what the distribution looks like. And then you have a ton of other scenarios that can cause estimates to not be correct. But stats and looking at what SQL Server thinks is in the table and what actually is typically where you want to start. So you need to understand how to look at that histogram like we showed in the beginning. So we looked at how to do that. We looked at what happens when stats don't go so well, when they're not being updated, and we talked about how to update stats. I've got a lot of references here that I'm going to kind of slowly go through while I'm looking at your questions. So if there's a question is, would the adaptive join feature mitigate what I am showing? So yes, right, that's designed to help a parameter sensitive problem, assuming that I'm going between a nested loop and a hash join, which I was in that example. So in the adaptive join scenario, which was introduced in 2017, right, you've got to have the appropriate compat mode there for that feature to be in play. 2017 was column store, 2019 supported with row store. Yes, it would flip between that based upon the number of rows coming in. Victor said, did I enable auto stats after the update? I enabled it somewhere in the middle of that demo, but initially I had it turned off so that you could see that if I'm not updating stats and I'm changing lots of data, the optimizer does not have great information. And then Rohit says, does table partitioning switching affect statistics? That's a really great question. So the challenge with statistics and partitions is that by default, unless you've got incremental on, you have one statistic, one histogram for the entire partitioned table. When you enable incremental stats, you do get stats at the partition level. The optimizer doesn't actually use them, but it does incorporate that into the overall histogram so that you don't have to go and update stats across the whole table. So to answer your question, when I partition switch, when I switch in, I want to update stats for that partition, and then those will get folded into the table partition. Okay. Hi, Fred. How are you? It's nice to see you. I've come up right on my 2:10, which is I know when Bob needs to hop in and start his session. So let's see. Do I recommend, so Eswar says, this is a great question. Do I recommend managing updates? You guys can hop in and chat and do whatever while I'm doing this. Managing stats manually instead of enabling auto update stats. That's a great question. I want you to do both. I want you to keep auto update enabled just in case, but I want you to manage stats with jobs. So I want you to do both.
Wow, Erin, that was a really great session. I've been looking at the comments. Right, you are so quick at looking at the comments, and while you're giving the sessions, right, you're answering all those. So that was done very nicely. And there's so many demos, so many best practices you have shared. Amazing. I think you have covered as much as content it could be covered in like 45 minutes.
I tried, yes.
That was really great. So thank you so much, Erin. Thank you so much for your time. We really appreciate for all that you do for the community. Definitely looking forward to host you in this coming year. And just thank you so much and have a nice weekend ahead.
Thank you. Thanks for having me. Thanks to all of you who attended. I appreciate it. And again, if you have questions, definitely reach out. There is a lot to know about statistics for sure. I'm happy to help you all.
Look at the comments coming in.
All right.
All right, Erin, thank you. Thank you so much. Bye. All right. So after that session, we now move to our next session. I'm really excited for this one, to be very honest. We have now Bob Ward, who's going to talk about SQL Server Containers, and you definitely don't want to miss this session. So let's go and invite Bob Ward and play his introduction video. Howdy, Bob.
All right, I love that. Howdy. Yes, you've learned how to talk Texan. Very nice, Erin. Very nice.
So
wow, that's a pretty cool video.
Yeah, you love it. I'm gonna tweet it after this, right? Your session. I'm gonna tweet it and tag it to you. Thank you so much for your time, Bob. Really exciting to have you back. We had you last year, right? It's always been a long time, right? So
absolutely. Thanks for having me. Enjoy being here. And by the way, just want to quick call out. I was watching the very end of Erin's presentation. It's so good to see her face. I used to seeing Erin at conferences in person. Consider her a close friend, despite the fact that she's a Cleveland sports fan. Anyway, that's a joke between us. But by the way, if I had to pick anybody in the community that I would want to learn more about performance, statistics, plans, query store, I would pick Erin Stellato. I mean, she is so knowledgeable in this topic, and she has such deep experience on it. So I'm glad you had her in the conference. So it's a great topic, and I'm glad you had her here in the event.
Yeah, definitely. I think even if you look at the comment, people really love her. People are still thanking her that was a great session. So definitely honor for us to have Erin and Bob. I think we are already 5 minutes above your session. So I'll go ahead and let you share your screen, and then you can go and get started.
Yeah, I'm shared out. So if you can display that, I'm ready to go.
That's perfect. There you go.
Okay, let's get going. Welcome everyone. This is pretty rapid stuff if you're just watching back-to-back sessions, right? You're jumping around to all sorts of amazing sessions in SQL Server. And huge call out to Simon for putting this together. I know so many of you are dying to see people speak in person, but it's so amazing people like Simon would put together a virtual event so that we can continue to empower you with the knowledge about everything SQL. And so when Simon and I were talking about what should we do with what should Bob do at this conference? Because I've spoken on a lot of topics over the years. As you saw on there, it's actually now 27 years, Simon. Can you believe that? 27 and a half years. Anyways, I thought SQL Server Containers would be a perfect topic for this conference. I know several of you on this event that are watching and listening are developers. So let's talk about it. But first of all, I want to make sure you are set the stage and have the resources you need. Look at this screen. At this link right here, AKMS Bob Ward MS, which I'll show you again at the very end in resources, the deck is already there. Everything I'm showing you right now in a slide deck, you can go to that website and see this deck. It's under a folder called SQL Server Containers. Let me also show you another resource. Let me pull this over here to the screen so you can see it. This is called SQL Workshops. This is a free GitHub site. And if you scroll down to the SQL 19 workshop, again, everything free on GitHub here, completely for your use. If you scroll in here, the scripts I'm going to use today are right here. You're going to see me go through using PowerShell certain steps on how to run SQL Server containers. So if you're like, hey, I'm watching Bob doing this, I need to get these scripts, they're already for you out there. Okay, and I'll give you these resources again at the end of today's session. Okay, let's go back and let's start talking about containers. So first of all, I kind of want to set the stage a little bit on a few basics of containers. The deck that's out there has some hidden slides of things I'm not going to show you because I only have like 45 minutes, to talk about this topic. But here's just a couple of basics because I'm going to talk more about just SQL Server containers. So first of all, I always like to use this slide to explain my version of what containers are. And the number one thing I emphasize is right here. That containers are really a process run in an isolated manner. It could be multiple processes actually, but many containers are just a single process. You'll see that with SQL Server. So it all starts with something called an image though, an image being a layered snapshot of files, the minimum files you need to run this process structured in a file system. So these images are really cool, and you're going to see how SQL Server provides several images for your needs to run SQL Server containers. Now, when you have these images, a container itself is going to be the runtime instance of the image. And something called a container runtime, and today's example is I'm going to use Docker, is used to go run those processes, these instances of these images. And you're going to learn today in SQL Server some of these other concepts like what's a writable layer and a read-only shared image layer, et cetera, et cetera, et cetera. So I just want to make sure you understood that. A lot of people I've heard say things like containers are lightweight virtual machines, and there's all these things out there, what they are. And look at the top of the right-hand screen here. A virtual machine emulates hardware and loads the entire operating system. A container is a process run in isolation, but cooperates with the host kernel. So you're going to see that actually in the real world, containers complement virtual machines. A lot of people run containers in virtualized environments, and you'll actually see that in example today. Now, there's a couple of things about containers I want to tell you. Number one, under the covers. I'm an under the covers person. I don't know about you. I like to see how things work. It's like, how does Docker, one of the most popular container runtimes, do this? Is there some magic to Docker? Well, as it turns out, not really. There's actually an open source piece of code called libcontainer, also called runc, based on this OCI, Open Container Interface. Libcontainer contains all the source code to do containers, to run containers. And in Linux, these are the concepts from the Linux kernel that are used to make this happen. Like a namespace is used for isolation, or the union file system to layered file systems. That's how we do things like sharing read-only file system images and do writable layers, or control groups, allowing us to do things like governance and accounting or limits of processes. So as it turns out, you too could write a container runtime if you wanted to. You could follow this open container interface, but you could just use concepts from the operating system yourself. And these concepts are used in places outside containers. Now, the last concept I want you to understand, it's really important because this comes up all the time when people ask me, how do Linux and Windows containers work? How does Linux containers run on Windows? So first of all, a Linux container image on a Linux host, that could be a virtual machine, could be bare metal. It's a native Linux process. You could go into the Linux system and see the SQL Server process run on the Linux kernel itself if you're running container image, okay? That's important from a performance perspective that you understand how SQL Server performs as a container versus running SQL just say in the VM itself. Okay, what about a Linux image on Windows? Well, for the longest time, it required an entire virtual machine running on Windows to make this happen. But now there are two technologies. One's called Linux Containers on Windows and WSL, Windows Subsystem for Linux. They support the concept of a virtualized process, but it's still virtualized. So for example, if you're going to try to compare SQL Server performance on Windows as a SQL Server Windows program with a SQL Server container Linux image, that wouldn't be fair because there is still a virtualized process involved and a layer there that could not be fair to compare performance. But if you ran the SQL Server image on Linux and a SQL Server Linux container image on Linux, it would be the same because it's a native Linux process. Now, on Windows, by the way, which today we don't support SQL Server Windows containers, we're still kind of trying to see whether people really want that. We don't see a lot of demand for it, but just so that you know, a Windows image on a Windows host can run in isolation as an actual native Windows process, but we also support something called a Hyper-V isolation. And then today, at least not yet, it's not possible to run a Windows image on a Linux host. So I put this together. I've talked about containers for the last several years. This answers a lot of questions people have about actually how does this work under the covers. Okay, let's go talk more about SQL Server containers now. So first of all, why do you do this? Like, what is the big deal about this container thing? And let's talk about these a little bit. Number one's portability. And I look at it this way from this perspective. You have developers in your organization, and you have a developer server for SQL Server you all share. DBAs can't stand that. Sorry, developers, you're always wrecking the SQL Server. You're changing the configuration, you're running something. You guys are all messing it up because it's shared. Well, go start running containers. Container images are portable anywhere you can run the container runtime. So for example, the SQL Server container image for Linux runs the same and is portable on Windows, Mac OS, and Linux itself. That's pretty cool. So if you've got Mac developers, Windows developers, all trying to run SQL Server, just give them container images to run on their laptops. And we'll talk about how you can use a consistent image of SQL Server along with scripts and other things to give them a complete package to do development testing in their environment. In fact, quick story. So I'm at an event several years ago. You may have heard of it called SQL Bits. And someone in the audience saw me presenting like this and said, hey, I'm not feeling the Mac love here. Bob, you're a Windows guy. You're running a Windows laptop. You're doing everything on Windows. What about Mac people? I don't want to run Windows. I'm like, I got you covered. In fact, I did a challenge for him. I said, within 5 minutes, you can run SQL Server on Mac and a native tool to connect to SQL on Mac in 5 minutes with no Windows software. And he's like, I don't believe you. And I said, well, feel free to get on Twitter and say I was wrong. And so the next day, somebody pointed out to me on Twitter that he said I was wrong. And I was really disappointed. I'm like, man, I really screwed up here. He said he actually did it in 3 minutes. And what he did is he installed Docker on Mac OS. He pulled down the SQL Server image on Mac OS and installed Azure Data Studio on Mac OS, which there's a native Mac version for. And in 3 minutes, he was up and running. So don't believe that you can't do things now. It's all just Windows-based. SQL Server supports these environments all over the place. Now, why is it lightweight? Look at this example right here. Because the fact that containers in their image only need the files they need to run the container image, not the entire operating system like a virtual machine, it reduces the footprint of running multiple SQL Server containers. In fact, in this diagram right here, it could be a virtual machine that's hosting all three of these. This is the new way to do, quite frankly, multiple instances of SQL Server in a more condensed way to compress how you install SQL. So, and then finally, it's much more faster to deploy this. There's no patching required. I know you're thinking that's crazy, but I'll show you how, and a lot less downtime. Now, if you're a DevOps, and we'll explain exactly how that works in a second. Now, if you're a DevOps person and you get the slide deck, go click on this link for this video. At the Build conference in May of 2020, I did a demonstration of how to use Azure DevOps with SQL containers to automate the development production lifestyle. I think you'll love to see that demonstration. You can go through and see exactly how I did it, how I built an Azure DevOps project, use SQL containers to make simple GitHub changes that automated the entire process. And so SQL Server, we believe, is a big part of the DevOps lifecycle because we now support containers. Okay, so let's move on for a second here and talk about the images of SQL Server. How do you find these things? So first of all, the Docker Hub and Red Hat Container Catalog are great places to see where we show up as container images, all the different flavors, okay? But we keep them in the Microsoft Container Registry because that is owned by Microsoft, and we ensure the security of these images in that environment. Now, what do we provide? For SQL 2017, this is where we first started with Linux containers. Every single SQL 17 build, the GA RTM of SQL 17, each cumulative update, each security update that we have, all have separate images, and they're all cumulative. So you can go right to SQL 17, cumulative update, whatever, and there's no need to apply the general availability and apply another version like you would do in, say, Windows. And it includes the SQL engine and tools packages. In SQL 19, we now have upped the game. We provide different versions of Ubuntu per your needs and different versions of Red Hat now based images. But again, we also have general availability, cumulative update, and GDR packages. So you're thinking to yourself, what about that faster deployment thing? What did he mean by that? Check this out. SQL Server now, SQL Server is pre-installed in a container. When you see me run this thing, it's all ready to go. There's no installation required. You just run the container and you've got SQL installed and up and running. and the tools are pre-installed. And then the other part that's amazing, this is the SQL Server engine on Linux. So database and applications are completely compatible. You're just connecting to the SQL image like you would SQL Server Linux. And I've talked before in many different other sessions that SQL Linux engine is the same engine that we run on SQL Server on Windows. So don't think that all of a sudden now I run a SQL Server container and I'm going to make all these changes to my code. No, just take your code, take your Management Studio tool, Azure Data Studio, point it to SQL Server Container, and you're ready to go. So those are the different engines of SQL Server, and this is why you're going to want to use containers. This pre-installed concept, I've seen a lot of people now in the industry that are doing demonstrations for SQL Server. Speakers are now completely using containers in their laptop because it's so fast and easy to get this up and running. Okay, how do you do this? And this is an example using Docker, and we're going to see this as a demonstration in a second, but I thought it important to kind of walk through the pieces of this. So first of all, when you run a Docker container, you can pass environment variables to the process that's going to run the container. In this case, it's SQL Server. So we have documented there's a link for this, we've documented what are environment variables that are possible for the SQL container. Now, two of these that are required are accepting the EULA, the license agreement, and the SA password. Because right now today, even though we've started support Active Directory authentication, in order to get this running, you must supply an SA password. Now, you can also use other environment variables, like if you want to enable SQL Server Agent, you can do that at the same time. You're going to see as well, I'm going to encourage you that if you want to make configuration changes to SQL, to the instance like memory, you could do it through the same concept when you run the container. The next is the port. So SQL listens natively on port 1433. And if you were to run several SQL programs that all tried to listen on that port, they couldn't do it. You'd get an error. So therefore, you can map ports. So I typically do this no matter if I'm running 1 container or 5 containers on a VM or a computer. Now I will connect to port 1401 for this specific container to get to the specific container instance that I just ran. The volume becomes very important, and we'll talk a little more about that later, but this is where you're going to be storing your databases and files to ensure something called persistent storage, because if the container went away, you would lose your databases if you didn't do this. And we'll talk more exactly what that means. But this name SQL volume, Docker is going to map that to a known directory on your host or your VM system where these are going to be stored. But everything inside the container is going to be in this directory, which for Linux is where we store typically the system and user databases. Now I'm going to use the host name parameter here because the host name is going to map to ADAPT server name. That's kind of convenient, especially when you're doing things like linked servers or distributed transactions. Now, the name parameter is simply a convenience to use with, say, like the Docker client. So when I use other Docker commands, I can reference this container by a known name that I use versus like a GUID that would be the default for what Docker provides. -D is an interesting one. This says, run the process for container in the background. Now, if you didn't do this, it would be an interesting exercise if you ran this without this on your own when you try these labs out. Because what's going to happen is the SQL Server process is going to run as a foreground process, and it's going to dump out the error log on your screen, which is SQL is designed to do as an engine. So we put this in the background so that you don't dump that information out, but it could be an interesting exercise for you to debug SQL if you had a problem running the container. Just take this off and see in the error log entries if there was a problem. And then finally, the last piece of information is, what is the image to run this container? For SQL Server, notice the nomenclature here. And then we have something called a tag. You'll notice here the tag says MS SQL Server and then some long thing, which is like the version, the cumulative update, and what operating system is part of this. And again, I pointed you to the Docker Hub and Red Hat Container Catalog where we list out all the different instances of the images you would want to use. So in this case, when I run this container, I'm going to be in a pre-installed version of SQL that is SQL 19 based on cumulative update 6, based on Ubuntu 18.04. So that's the specific need I had in this case. So that's how the basics of how to get going and to run a container. Now, in a second here, I'm going to show you a couple of things. And before we do a demonstration, I'll stop and I'll see here whether there are some questions. How do you actually update a container? How do you update SQL Server in a container? You now have installed this container, but you're not sure what to do. Well, first of all, just interact with it like a SQL Server. Use your normal T-SQL, an app to modify data. It's just the SQL engine. We're going to talk about persistent storage in a second, so your databases are all around. And if you want to do a backup restore, I'm going to show you an example where you can take a database backup file and copy the file into the container file system and then restore it within that file system. And then, as we talked about, and I'm going to show you, we're going to use something called a volume to make sure your changes are not lost if the container gets removed. So that's just interacting with like changing tables, creating tables, doing normal SQL operations. Well, what about configuration changes? That gets a little more interesting. Number one, I recommend you, as much as possible, use environment variables, which are typically stored in what's called the MS SQL comp file. And there's a link to how to do this for a lot of different configuration needs, whether that be memory limits or whatever it may be. You could modify the container directly with spconfigure and alter server configuration, known T-SQL commands. But remember, once you do that, you kind of lost the whole concept of containers being consistent. So what I recommend more than anything else is build a new image, a customized image based on SQL, using scripts to use these kind of T-SQL commands to configure the container per your needs. And I'll show you an example of that a little bit later. So, and that's one of the huge promises, I think, of containers is this consistency concept where you can customize things consistently the way you need it. So for example, if you wanted to have a SQL server for all your developers where max degree of parallelism is set to 4 or whatever you want it to be, you might build a custom image with a script that's going to do that, and the developers use that image. You know it's always the same across all your development, your development group. Okay, let's stop for a second before we do a demo and see what kind of comments we have here. Can you create an instance name in Docker? Server name, instance name. Oh, that's a great question. So there's no concept of named instances in SQL on Linux. We don't have that concept. And in fact, containers are the way to do multi-instance operations. So we'll show you a little example, talk more about that in a second, but that's the way you're going to normally use containers, is create several containers, and each of them now represent an instance. And then the way you can refer to these as names, by the way, is use host name, that parameter I showed you, or also use the Docker client name, so you can refer to them outside the container and inside the container per a certain name. But there's no concept of a named instance in Linux, but that's okay because containers give you this multi-instance concept. Okay, let's flip over and do a demo. Let's do some fun. Let's do it this way by using Visual Studio Code. Okay, what I've got Visual Studio Code pointed to the GitHub repo with all the scripts I told you about. And up here at the top window is the first script to go learn how to run a container. Notice the syntax looks very similar to how I showed you in the slide. And I'll point out a couple things. I'm going to make sure that the name represents the specific SQL Server CU image I'm using, which is CU6 for SQL 19, cumulative update 6. But all the parameters look the same. And here's the name of my volume, SQL 19 volume. That's going to become important here in a second. So I'm going to, at the bottom down here, use the terminal window to kick off and run this. So let's do this. Let's go type in step 1, and we're going to run our container. Now, container images are pulled down from the internet into your environment. And there's all sorts of documentation how to do that offline if you need it on your servers. I have pre-pulled these because if I didn't, it would try to pull it from the internet. I would slow down our demonstration today. So notice how quickly this is run because I've already pre-pulled the image. I'm now running, and guess what? I've already SQL's installed and running. That's how quick it can be once the image is actually pulled. So the next step I'm going to do is I'm simply going to go copy a backup database. Notice here this syntax here. I'm going to use the Docker copy command here. See that? And I'm going to take the local database backup, and I'm going to copy it into the container that I've just started and into this directory, var opt.ms SQL. Let me scroll over so you can see that. var opt.ms SQL. What is that doing? That's taking the backup file on my local drive on my Windows laptop, copying it into the container's file system so it can be used. That file system is backed up by this volume concept, which we'll talk a little bit more later about how does that work internally. So I know that my backup I've copied in is persistent. So let's go run a script like this to go actually copy it in. So let's run step 2. I've got these step by step for you so you can see step 1, step 2, step 3. It's already done. So step 3 requires a restore. Well, how do I do that? This is interesting. I'm going to do something really crazy. I'm going to use Docker to run another program, another process in that container image. What is that container process? SQL command. Because we install the tools, pre-install the tools inside your container image. So now I can actually go there and run this command inside the container isolated environment as a separate program now as from SQL Server. But since it's part of this container, they're both in the same namespace, so they know how to talk to each other. So here I am simply running this complete restore command because this is where I put the backup itself. So let's go run that. Oops. And this is now going to do a simple restore. And this backup is based on SQL 16, so it has to get upgraded, but the engine knows how to automatically do that since it's SQL 19. And again, this is no different than if I connected outside the container, which I'll show you an example how to do that in the next step. But I wanted to see you different ways how you can interact with SQL. I'm going to run a program inside the container. It's out and it's ready to go. This is an example of how to query it. Now I'm running SQL command as a Windows program on my laptop connected in the container. How do I connect? Well, I already told you. I said use port 1401, and this is the local host because it's just running locally on my actual laptop itself. So I'm running, first of all, a query here to just select data from the database, and then I want to get the version. I want to get the version to show you how version updates and patching are going to work. So let's go run this one. Step 4. And you see here I've got results that are flashing across my screen. And I can see now the version of SQL Server I'm running right here. It's CU6, right? You can see I'm running on Ubuntu 18.04. So what have I done? I run the container. The image is already pre-pulled. I run the container, and in seconds, I'm up and running. I copied a backup into the file system that's part of the container image itself. Docker knows how to interact with that. I then ran a restore command using SQL command in the container, and I just ran a simple query against it. I could have taken Management Studio on my laptop and done the same thing as these queries right here. But for purpose of automating this, I'm just showing you SQL command. I could use Azure Data Studio as well. That's as easy as it gets to start SQL Server and start running it. We're going to see in a second here, after I show a few other slides, how do I update this? How do I patch SQL Server? Because I said no patching required. What's the magic of all that? We'll show you in a second how that works. Okay, back to our deck here. Let's go back over and see if there's any other questions we got. Okay. So is containers mainly for DevOps, or can they be used for production workloads? Wow, what a great question. Checks in the mail. So I showed you just a basics here of using Visual Studio Code, and I talked about DevOps. But remember now, the concept of DevOps is that it is now a production kind of thing, right? But I also talked about how containers can be used in development environments. I'm going to end today's session with a slide to show you that containers for SQL are ready for prime time for production. So we'll explain more about that later in the talk. Okay. Now let's move on and talk about what I just kind of mentioned about multi-instance. So number one, whenever you run multiple instances of SQL Server, a lot of people like to affinitize CPUs or use resource governor, those kind of things. You can use different container runtime options like CPU set or weights and quotas with Docker. Docker supports that. Or you can use SQL commands to do it yourself. I recommend you use SQL commands. Use the power of the SQL engine that we've already provided to affinitize or control how SQL is running from a CPU perspective. Again, one way to do that might be to use like a customized image of SQL. The other thing is memory, same thing. Remember I talked about how you would use environment variables? Like I would use the memory limit MB option as an environment variable to restrict the memory for a container, but you can also use max server memory, fully supported. You would again, maybe potentially use a customized image of SQL with a script that does that for each instance that you're going to run. Why do I say this? Because a SQL Server container instance, if you have multiple, are all going to use the maximum resources that are provided in the host, whether that's a VM or bare metal. And then finally, networking is interesting. By using the host name, you automatically have some things set up for you. And like a Docker environment provides things like bridge networks to allow you to communicate between these instances. But there is the ability to use what's called a user-defined bridge network to do name resolution. Very helpful for things like replication and DTC. I actually have an example of that. I'm not going to go through that example, but in the workshop, I'll show you just briefly where you can get the scripts to see how that actually works. Okay, what about this idea of patching? Like I said, you don't have to patch your SQL Server anymore. And you're like, I don't believe you. Like, what do you mean? Because think about today in Windows. Today, you install SQL Server 19, general availability. Now you get a cumulative update that comes along from Microsoft, and you want to put on that update. Well, what do? You install the cumulative update. And then the next cumulative update comes along, and then you go install that one. So what you're doing is patching the software. We don't do that with containers. You just use this switch method. So first of all, consider this scenario. You've got what's called a volume, which I've kind of showed you how you might use when you run a container. This is persistent storage of your databases, because each container image has their own private file system. And if they were removed, you'd lose it. But if you use a volume, you're redirected to this known space. So let's say the SQL 17 CU8 container is up and running, pointing to these databases, and you'd like to move to the latest cumulative update. Well, how do you do it? So number one, what you're going to do is you're going to stop the container for CU8. The databases are still here, but you're going to effectively shut down SQL Server. And then very quickly, what you're going to do is turn around and just run the latest container CU based on a new image. And what you're going to do is point it to the same volume with the same port and everything else that I showed you. And now within seconds, you've updated SQL Server. That's your patch. It's called the switch method. But you're asking yourself, well, that's really interesting. How can I go back? Cumulative updates are compatible between each other. So guess what you can do? If you don't like the results, you could shut down this container and then restart this container, and now you've rolled back. That's how fast it could be, or you could switch back and forth. So when I show this in action, which I will in a second here, people are amazed and think I'm like lying to them, but it's true. And one of the ways you can get away with this is the fact that I'm using a volume where the system databases and user databases are, and I'm using cumulative updates between each other. Now, you can upgrade based on containers. Like I could start SQL 19 and point into these databases here, and now I've done an upgrade, which will take longer. But because major versions are not compatible between each other, I can't go back at that point. So there'd be no way to switch back to SQL 17, but it does provide a way to actually do a very simple upgrade in line. Now, again, this is just the SQL Server software. If you wanted to take databases and go between them, you can take a database from SQL 17 and apply it to the SQL 19, and we would upgrade that automatically. Of course, you can't restore that backwards. But again, this is just talking about the instances themselves. Okay. So let's talk more about these volumes, because it's really important for you to understand, what do I mean by these volumes and databases going away or not going away? So assume for a second there's a SQL Server container, okay, where the databases themselves are kind of contained in the private file system of that container. But since I've used a volume on host storage, again, the container runtime will take care of all that for you. Since I've got this host volume, the files are actually pointing in this host storage directly. Now I've got a SQL Server 2 container that's not started yet right now, pointing to a separate set of files. Okay, let's say, for example, I stop SQL 1. I stop SQL 1 right here, and then I start SQL 1 again. No difference. I'm just starting and stopping SQL Server, so there's no differences that are happening here, okay? Now, let's say, in the case of SQL 2, I stop SQL 1, or in the case of SQL 1, I stop SQL 1, but I then remove the container. So what happens? I stop the container, I remove it, and notice here that when I do that, the files are also removed as well. Now, again, this is a case where if I go back here, so let me go to SQL 2 and show you that behavior. So let me go back here, back to this. Again, this is an example where the container is not using persisted volume. I'm sorry, I did not explain this clearly. This is SQL run running a container where the host is keeping the container runtime file system, but it's not persisted because I'm not using this volume concept. So when I stop the container and remove it, I actually do remove all the files because this host storage is backing up the container temporarily. But if I go do this concept where I store the databases on a host storage volume now, okay, host storage volume, and then I go stop and remove the container, what happens? The databases are still there. This is why using volumes are so critical to using in containers. Now, if I go back and look at the scenario, and then I stop SQL 1 and start SQL 2, you're going to see what the behavior looks like, just slightly different here. Ah, look at that. I can point SQL 2 to the same volumes. That's what I showed you in the switch scenario. Because I'll use host storage volumes, notice that the databases, in the case of host storage, are not stored over here. These are the temporary file system spaces for SQL 1 and SQL 2, not the host storage volume spaces. Even though the host is storing them, think of that as temporary storage spaces only for the lifetime of the container. So for SQL, as a product with persisted needed storage, I always want to use this host storage concept. Okay, so let's now go look at what this looks. Let's based on our time right now, let me just briefly talk about this, but I also want to get quickly into the demonstration to show you how to go do an update. So I mentioned about this idea of customizing images, right? That maybe you want to customize with scripts and so forth. So you might ask yourself, like, how do I do something like that? So for Docker, if you use that runtime, there's something called a Docker file, which is a declarative file where I can say, I'd like to build my own image, and Docker supports that. You can build an image, then run the image. So I could go into the Docker file and say, I'd like to use this as the base of my image. And I want you to, when you build this image, to copy a backup file into the image itself, to the snapshot. And then the program I want you to run is SQL Server, as it's customized. So when this is done and you build this new image, you can call this whatever image you want. In that image will be the SQL Server software plus your backup. Then somebody could actually just run restore at that point once the container is started. What if you wanted a more script type method? I call this the VinU method because my colleague VinU from Microsoft is the one that showed me how to do this. So here is a Docker file where I'm doing the same thing as before, but what I'm going to do is I'm going to copy in a series of scripts into the image now, and that script is going to be what's going to be run, not SQL Server. The script is going to eventually run SQL Server. So what happens first is this. The entry point script will run two programs. It'll run this shell script and SQL Server asynchronously. Okay, that's what that ampersand means. Then the DB init script will wait for SQL to start and then run, because SQL command is installed inside the container, a SQL script. The SQL script can be whatever you want. In the example that I have in our workshop, I show you how to actually run a replication environment, transactional replication, using this method with scripts that build the publisher, subscriber, etc. But this script could be any T-SQL set of commands. It could be sp-configure. It could be creating databases. It could be creating tables. So think now of using this method to build a customized image for your developers on a certain version of SQL with specific SQL configuration options that you want and with all the SQL commands you'd like them to use. You could provide them a complete shell database, for example, based on exactly the schema you wanted them to test on. Okay, and then there's ways, by the way, in this same process to add other packages that we have for SQL Linux, like Polybase, machine learning services, etc. Okay, so let's stop for a second and look at our comments and go back to the actual example I'm going to finish with here. Okay, so let's see here. What is the presentation software website that he's using? I'm not sure what you mean by that. I'm just using PowerPoint. And of course, Simon is providing our environment here that we're using for StreamYard. What do you recommend for separation of the files or for the backups? Yeah, great question. Same concept will apply for production environments. And you have the ability for containers to have separate volumes. So you could have separate volumes to store different files in different locations, depending on where you want that host to go. And the containers certainly support that. Where do you get a link to the sessions that this session is provided? I gave you at the start of the presentation where this talk is, but the last slide I have also has a resource to that. How do I start using C#? I'm going to let Simon answer that for you. And then, does the SQL Docker version have the same functions as a regular SQL Server like Polybase? Great question. The SQL Server container images we have right now are the same SQL Server engine as SQL for Linux. So whatever Linux supports for SQL, we support that. And I just showed you in the very last slide there that the SQL Server container images contain the engine and the tools, but there's ways to install the other packages with your container image, including things like Polybase. All right, let's go do another demonstration here. Let's go back to Visual Studio Code. So here is the script to patch SQL Server. I'm going to run it first, and then I'm going to talk about it. So let's go run step 5. And what is it doing? So first of all, it's stopping the current container. It's running another one. Look at that. Same port, same host volume storage, different host name, different name, and wait for it, different image. This is the CU8 image. So I'm stopping the CU6 image. I'm starting with a new image with CU8. So the CU6 container is not removed, but just stopped. The CU8 now starts up, points to the same databases, and since we're compatible, we handle everything for you in between. So this is running, and it's already finished. So what are we doing in step 6? Step 6, and I won't do this for you, but it's an example of how to run a different container. Let's say that I'm running this CU8 container that's patching SQL, but I want to run a different one. Well, how do I do that? This is a general availability release of SQL 19. Notice a couple things that are different. A different port and a different volume name. I want to separate a different instance of SQL here than the one I'm trying to patch. And this is an example of how to run a second instance. So this is a command just to show you, well, what are the containers running in my environment? So let's go run that one. Step 7. And this is interesting when I run this. When I run this, I'm going to see a couple things here. I'm going to see First of all, I'm going to see the CU8 image, which is now up and running. But notice that the CU6 image was exited. It just means that the container was stopped, not removed. So the reason why I didn't remove it is I might want to switch back. I could go down here and inspect volumes. Let's go run a query and see what we get here. Let's go run step 9. Again, you can run some of these other steps if you'd like to after the fact. This is just running a query. And notice it's running against that. But when it's finished, what do we see? We see now that we've updated to CU8 right here with the same SQL Server, the same data, the same database. That's how quick it is to patch SQL Server. So, and again, I don't even call it patching. I call it switching or updating. And so if I wanted to roll back, I would simply do this. I would stop the current CU8 container, not remove it, and then start back the CU6 one that I didn't remove, but I just stopped. So let's go do that. So we're in step 10. And now I'm in the process of rolling back. Now, if you're asking yourself, like, do I get to see things like error logs with containers and things like that? Look at step 11. Step 11 says, go run, like I did SQL command before, go run another process that is in the same namespace as this container, but use the bash shell and make it interactive. So look at this. This is kind of fun to do. Let's run step 11 here. Now I am put with a bash shell prompt. But Bob, you're running PowerShell. No, I'm actually put forth a program that Docker supports running in my namespace as a bash shell. Now I'm running in the container itself. So I could say var opt msql log, that directory, and I could do this. I could look at the error log. Looks pretty familiar, right? That's the same error log as you're used to in SQL Server. This is the error log of the SQL container I just rolled back to. So it looks like recovery is complete. It's done. So I now can do something like this. I can go back and run step 14. Oh, I'm in the bash shell still. So let's exit out of there. I'm back to PowerShell now. And now I'm running my query again. And when this is the same database I ran a query against, so it's consistent. And now I'm running at CU6. Simple rollback of what I did. I updated my container. I patched it to CU8. I stopped it. I started CU6 pointing to the same set of databases because cumulative updates in SQL Server in the same major version are compatible with each other. That's as easy as it gets. And that's really an amazing way to be able to patch or update the SQL Server version of the software. Okay, let's look at some other questions here before I go back. How do you create Docker container for SSAS, IS, and RS, possibly in Linux? So it's a great question. We do not support native versions of analysis services or reporting services for Linux today. We do support SSIS, though, the DT exec program, and we have some documentation about how you could create a container image for that. Are you running an admin mode with Azure Data Studio PowerShell terminal? I'm just running the terminal on my local laptop, so I'm not running any special mode there. I'm just using actual Visual Studio code, but great question. I could have done this in Azure Data Studio. I could have used Azure Data Studio as my environment and ran a terminal inside it and ran queries in Azure Data Studio as well. So that would be a great suggestion for the future. I do like using Visual Studio Code for just raw developers, but Azure Data Studio is a great environment where it supports a similar environment just like this. And it does support PowerShell notebooks. So another way to do this is to take these PowerShell scripts, put them in notebooks, and then run them from that perspective. All right, let's go back over to our PowerPoint presentation. We've got 6 minutes left, a little bit pressed for time, but that's okay. If you think about it, let's just stop and think what I've done, right? I've talked about the power of containers, why you want to do it. I've talked the basics about how to get these things up and running. I showed you some examples of how simple it is to do that. And then I showed you this idea, it's pretty cool, of running multiple SQL instances as containers, but even this amazing story of how to go patch a SQL cumulative update without truly patching the software. In fact, that is the world you're in with containers now. Don't patch anything. Just run a different container image and point it to the persistent volume storage that you already have in place. Okay, so this question was asked earlier. Are containers ready for prime time? Remember, a container for a SQL Linux image is just a SQL Linux process run in an isolated manner. So I have seen this stated before when I was on the road, the last year. Oh, I wasn't on the road last year, maybe the year before. But just in general, I've seen this from the community. Containers aren't as fast as SQL Server. I'm like, that's not true. If you're running SQL Server on Linux as a Linux image, remember that first slide I kind of showed you earlier, it's just a Linux native process. In the book that I wrote, SQL Server 2019 Revealed, I show you a test of using the popular open source tool HammerDB. A TPCH query runs 100% the same on a SQL Server on Linux as a SQL Server container on Linux. Again, if you're running in a SQL Server Linux container on a Windows machine, that's not fair to compare that to SQL Server on Windows, because there is a slight virtualized process there. Now, it may be fine for your needs, but I would not run that as a production workload. I would make sure that if I need to run SQL Server containers in production, that would need to be on a Linux system, a VM or a bare metal machine. But for development purposes, it's perfectly fine. Now, SQL Server 19, we run our containers as non-root now. This is something that we needed as a requirement to run environments like OpenShift in Kubernetes. So if you have concerns that our container images run from root permissions, they don't anymore. That's a change we made in 19. And then I always get questions about licensing. How does licensing work for containers? It's the same as virtual machines. In fact, we have a specific section in our licensing guide for SQL 17 and 19 where we talk about exactly how containers are licensed for how you purchase SQL Server. But keep in mind this. If you run developer version of SQL Server with, say, Ubuntu, everything's free. So you as a developer can be out there developing for free on your MacBook, on Linux or Windows, with no charge at all, using SQL Server Ubuntu-based images for Developer Edition, and that's the default. So when you run a SQL Server container, the default is Developer Edition. You have environment variables to specify if you want to run in production that it's Enterprise Edition. Now, consider this about production workloads. Most production workloads for containers are going to gravitate towards Kubernetes, which is a scaling environment to run containers. In fact, our big data cluster solution, we have a SQL 19, deploys some 50 plus containers, including SQL Server in multiple instances to actually make that solution happen. We just recently announced Active Directory authentication support for SQL containers. So if that was something that was blocking you from using SQL containers, we've removed that limitation and we have documentation how that works. And here's just a couple examples of customers I've worked with that are running in production today. DV01, one of our early adopters of SQL Linux, and Balzano, which happens to be running big data clusters on Kubernetes today. And it is an example of the power of SQL could be ready for you for containers for production. Okay, quick takeaways. They're portable, they're lightweight, they're consistent, and very efficient. Think about this idea. Maybe containers for you can become database containers. Maybe it's no longer thinking in terms of it's a SQL Server thing now. You build a container image with your database, with your scripts, with the SQL Server image you want, with everything you need in it. And you just give it to a developer and say, hey, there's your database. Go start using that now and not worry about all the intricacies of the SQL instance itself. Now, we talked about deploying. We talked about how they support DevOps. We understand how they work now, this new way of patching. And then I mentioned exactly that I think they're suitable for production environments. Keep it in mind, a SQL Server Linux container is the same process as running SQL Server on Linux itself. It's just run in an isolated way. Here's some resources for you. Shameless plug for books, right? There's a book on Linux I've written in 2018. In 2019, I wrote a book, and there's an incomplete chapter of how SQL containers work, including a lot of stuff I showed you today with more, that you can go take a look at that. Here's all the references. This is where the deck is. This is where you go get all the demos I just did. More demos here, more demos from the book, and then great talks you can take a look at. Here's a great talk that Vin, you did at Ignite a couple of years ago on how to do containers with DevOps. And then here's the video link from Build 2020, where you can see me show you exactly how to use Azure DevOps with SQL Server. And then here's a great book just in general to look and see how to get up and running on Docker. It's a great just general resources on how to use containers itself. I really appreciate your time today. Let's see if there's any other questions here. Have some documentation for AD authentication containers. Yes, Wilson, once you get this deck, if you go back here and look, I've got a specific link for you. You can click on right here, and it shows you exactly how to go do that. And what about Podman from Red Hat? We certainly support the Red Hat environments. We prefer that what people use with Red Hat today is like an OpenShift environment. I don't know specifically all the details about using Podman, but just to let you know, our images are compatible with running Docker as a client, but they're also compatible running other container runtimes because we support SQL Server running in Kubernetes. And in many of those environments don't use Docker, they use other type of environments. So, hey, thanks so much, Simon, for your time today. That was certainly a fast-paced look at SQL on containers. But I think hopefully everybody here got the idea of the power what they can provide and the value they can be for both developers and every professional out there that wants to use SQL in this new way to deploy and run SQL Server.
That was a very crisp session, Bob. I was just looking at the comments that we still have a couple of questions. We may take it later on, right? So I think we already have this time to go ahead and look into the other session. But amazing session, Bob. It's always great to have you in the conference and live events. Quickly, some of the questions that you said I should answer that. Where should you want to go and learn C#? Oh man, you want to learn C#? Go to C# Corner. That's where you want to go, right? And I think this question that the guy asked, what's the presentation software website using? He actually meant your Zoom it tool.
Oh yeah. When I do this right here, when I kind of do this and I start doing all these kind of things, like with my cursor. Got it. Yeah, that. Sorry, I'm not clicking on the right thing here. Yeah, that is called Zoom it. Yeah, exactly. Good call.
So I think that's it, Bob. Thank you so much for your time. It was a great session. We'd love to have you back, and thank you so much, and have a great weekend ahead.
Thanks for hosting me. Take care. Have a great day.
Bye. Take care. All right, so now we are done with that session, and now we move to our next sessions, and it's about executable troubleshooting guides with notebook for SQL people. And whenever I go ahead and read about this, right, a notebook with SQL people, I know many people joining this conference come from the SQL background, but the guys who come from data science background, they might feel offended that their favorite tool has been stolen away. And I came to know about this tool that even data science SQL guys use these notebooks, and I felt like, why do you guys use our tools? So to talk about this session, we have Julie and Erin joining us. So let's go and invite our speakers now. Welcome, Erin and Julie.
Hello, can you hear me good?
Yeah, you're all good. Audio's crisp, everything's good. Hi, Erin.
All right, great. Hey, how's it going?
Yeah, I'm doing good. Thank you so much for joining. What time is it at your place?
3 o'clock here in the afternoon in Atlanta.
It's noon here in Seattle.
And it's 1:30 a.m. at India.
Oh, wow. Wow, that's really early or late for you. Thank you for having us.
Yeah, thank you so much. I think we are already almost like 4 minutes more, right? So I think I'll go ahead and share your screen, Julie. I already see it. And I'm really looking forward to the session on what are the tools that you have taken away from us. So,
okay, awesome. All right. Thank you, everyone, for joining today. I really appreciate your time learning something new. In this specific session, Erin and I will actually go through some of the frameworks that we've actually discovered, and we wanted to share with you. It's related to executable TSGs or troubleshooting guides with notebooks for SQL people. So some of these learnings is actually quite amazing because when we first looked at notebooks, it was specifically for data science, which Simon sort of mentioned a little bit earlier. But it turned out that some of the simplest things that you do, or actually could be quite complex during incident response, can also be solved using notebooks. So today, myself, Julie Cosmano, and Erin are gonna talk about this a little bit more. And if you know Erin, he's gonna sprinkle a lot of PowerShell in this session as well. All right, let's get started. All right, our learning journey today. First of all, I'm going to set a basic sort of stage for you in terms of troubleshooting guides and what it means by notebooks. And Erin was going to talk about the executable TSGs or troubleshooting guides with notebooks. And then I'm going to show you some tips on how to jumpstart with the TSG notebooks and a couple of resources. The good news is that all of these resources are already, well, at least the slide deck is already available online. So if you go to the link on the bottom, the bit.ly short URL, you can go there and download this slide deck and follow along too. All right, let's jump in. Introduction to TSGs and notebooks. Okay, so in this specific session, when I mention TSG or troubleshooting guide, it could be it could encompass SOP as well as standard operating procedure. In some, I guess, in some of the companies that we have worked with, the industry also call them playbook or runbook. Essentially, playbook is steps to identify issues, which is very similar to troubleshooting guide. So it's the diagnosis steps. And runbook is when you actually want to achieve a specific action, usually to do with the mitigation. And in some cases, some companies just simplify this and call it knowledge base. Either way, it's for incident response, and that's what we're going to be talking about today. All right. Okay, before you run, and this is a bit of a warning because I have to say this, while we talk about tech, when you do roll this new framework out in your organization, it is about change agent. So before you run, I do want to share a bit of a lessons here. First of all, whenever you actually want to deploy this new way of, using notebooks or anything at all really related to incident response, make sure you know your goals, understand the gaps, and then plan for it and include the people who are actually stakeholders to incident response. And yeah, plan. All right, with that put aside, let's get started with notebooks in Azure Data Studio. All right, so let me show you this. So this is Azure Data Studio. And actually, if you followed along since this morning my time, Buck Woody showed a little bit about it. Bob Ward mentioned about it. And today I'm going to show you more about Azure Data Studio. And in the next session, my colleague Drew will also talk about Azure Data Studio. So lots of Azure Data Studio love today, so which is great. So this is Azure Data Studio. It's a client tool, and it is available on cross-platform, meaning if you actually run Mac OS or Linux or Windows, I happen to have this on Windows, by the way, this will work for you. And the cool thing about this is you can connect to your, say, SQL Server instance on-prem or Azure SQL or Azure Data Explorer from Azure Data Studio. But there's also a way for you to create a new notebook, and then this is how this works. So for example, file, and then new notebook. And then from here, you'll see a blank slate of notebook. So let me just minimize this a little bit. That way it's not too distracting. So this is a brand new notebook. First thing that you will see on the top here are a couple of things, cells and run all and kernel and attached to, and I'll go through each of them one by one really briefly. So in notebooks, there are two things that you usually care about the most because you have to write this or use this. The first one is the text cell, and the other one is code cell. So here's an example of me writing a text cell. Let me switch to rich text view because it's essentially just as if you're writing like a note, right? So let me type in hello world. This is my text cell. Such, and then I can also do formatting. So it's really nice WYSIWYG kind of way of entering your notes in notebooks. But you could also, if you're really good with Markdown already, maybe you use it elsewhere, you can go full Markdown and start typing, Markdown codes for your notes. And the next type of cell that I'm going to talk about here is code cell. So this is where you start typing in code. For example, select, top 10 stuff from sys.objects, and then you can run it against a specific connection. Now, before I get to the connection, you're probably wondering, well, that code cell there, that looks SQL, and that would work because I'm going to be running this against a SQL kernel. But I could also run a KQL query. I could also run PowerShell, which what Erin's going to show you later. If you're familiar with Python, maybe you're a data scientist or data engineers, you can use this too. So it's pretty cool. And here's another trick that I wanted to show you. And this is important to know because I think this helps you to kind of uncover more efficient way in terms of working with your notebook. So as an example here, I just right click and click new notebook. And from here, I'm already connected to my demo. But obviously, you could also change the connection from my previous notebook too. And then from this notebook, you can start typing the queries. So for example, the ones that I had earlier, let me just type this here. Whoops, look at that. Oh no, I just did a text cell. What's happening? Okay, I did a boo-boo, that's okay. There is a way of converting a cell to code cell like this, and I can start running it. And so this will give me the top 10 star of the objects. Voila. So what that really means is a notebook allows you to add text, which means you can provide description. It will allow you to add code as well as run it. And when you save this notebook file, the result set will actually be saved as well. So when you think about during the incident response, when you run specific code, you usually have to read about the context of what's going on before you run the script, and then you run the script so you see the results. Sometimes you have to do some auditing. So this is one great way of, working with incident response where you run the cells, the code cells, and saving the result set as part of that auditing step. Now, you're probably wondering, show me what that roughly looks like. Okay, so here's a template that I've created earlier. Let me jump to here. All right, so this is a pretty basic template on troubleshooting guide. So from here, I have a troubleshooting guide title, and this is just some guidance about what would be, great for troubleshooting guides, some characteristics of good troubleshooting guides. And then I have some content. So for example, overview, etc. So let's go and jump to some of them, perhaps symptoms. So when you do troubleshooting, you usually kind of have to verify that the symptoms are as what you expect. And then you go through the mitigation. That's to solve it. And mitigation step 1, 2, and as many as needed. And then you verify if what you have mitigated actually are mitigated fully. And then the next step would be obviously communicate to your stakeholders or whoever might be affected by the incident. So that's roughly a very super fast introduction of Notebook, what it is, how you can connect to SQL. You can connect to the SQL connection that I showed you earlier is actually connecting with SQL Server 2019, but you can also connect to Azure SQL DB or MI as an example. And then I've shown you a template, which is super easy to follow here. And I'll provide a link. Or actually, if you go to the GitHub page, the bit.ly URL earlier, you should be able to get to this page really easily. A couple of things before I hand it over to Erin. I do want to show you, you're probably wondering who else is using this. Now, if you are familiar with GitHub already, you probably are aware of the Microsoft GitHub. We have Tiger Toolbox. Azure Data Studio is an open source. It's also on GitHub, by the way. So Tiger Toolbox has got a lot of useful scripts, and one of them is troubleshooting notebooks. And then you can simply go to one of them. So, for example, this BP check one, and then if you go to raw, and this is actually a quick trick. See how this is all JSON? That's what notebook underneath notebook is about. So if I copy this URL, and then I go open here. So Control O, paste the raw link. It's going to load the notebook that you saw from here. It's going to start rendering it. GitHub in itself, if you check in your IPYNB file or notebook file, will render it like this, like as you see on the screen. Okay. There are actually a lot of community contribution, but I'll let Erin talk a little bit more about how he has used notebooks for troubleshooting in his daily work. With that, I'll hand it over to you, Erin.
Okay, great. Go ahead and share my screen. Let me know if you're getting any feedback on my mic.
You're good.
Okay. Oops. What did I do? Hopefully I'm sharing from correct monitor. Sorry for the delay here. y'all can just let me know when that comes through. Okay, great. Excellent. All right, so I've got kind of a variety pack of things that I want to walk you through today. A little bit on the troubleshooting side that's easy to show you, and then some other things. I'm actually going to pull in some pieces of demos from about 3 or 4 different presentations I've given, all of them with notebooks, and just give you different flavors of what you can do to create your troubleshooting guides. The thing about troubleshooting guides is something that's really, really helpful for my environment. Might be a little niche for your environment, so they don't 100% of the time carry over, but there are some generic ones that we can go through today, like the BP check that Julie mentioned, as well as the SQL assessment notebook that's also available. We'll go ahead and start looking through the BP check that she pointed out, and we'll walk through here. This is available up in the Tiger Toolbox, and these are in there as JSON. You can download these straight from there. Just do a quick call. This is all encapsulated in the notebooks that are out in my GitHub repo. And the notebook that we're dealing with is actually this one over here. So let's look on the right here a bit. We'll see that this notebook, it's actually pretty large and has something like 30 some odd different queries inside of it. And this could be that kind of notebook where you start with it and you go and you look for it. You look for the problem. So this could be, we need to gather some information and we don't know exactly where we're going to find that problem, but these are the steps we've used to get to that problem in the past. And we want these queries to be used anytime we want to run into this problem again. So obviously, some of these are just basic comments here. In your own environment, these may be more specific descriptions of the situation, or in some cases, they may just be like, run one of these 5 queries, and if you see one coming back with a lot of results, that might be your issue. You put in there in those markdown cells the important information to make whoever's using it, possibly you, but if it's the middle of the night, might not be you, hopefully not you, right, if it's in the middle of the night, and then might be someone else. So you want to give them a good guide as to what to do. So when you put these together, you can make them so that you can run through them and go through step by step by step, and you can do that to gather the information. There's another way that you can do them with the SQL notebooks, and I'll kind of refer to it. They're all Jupyter notebooks, but here in the data world that I live in, I work in mainly two types of notebooks. It's a SQL notebook, meaning that it is the SQL kernel that we have over here, or it is a PowerShell notebook, meaning it's either the PowerShell notebook kernel that comes with ADS or the .NET notebook kernel that comes with .NET Interactive, which allows you to do C#, F#, and PowerShell all in the same notebook if you so desire. So coming back here, we've got this notebook, and let's say I've got to run it, and I want to do my troubleshooting, and I want to run it on one machine. Well, hitting the run all switch is pretty easy, and I can go ahead and get information back from a whole bunch of different queries, a whole bunch of good information, and hopefully some of these queries can actually be written in a way to kind of help make it obvious once they discover an issue. Now, what if my situation isn't on one machine? What if I have 5 machines? What if I have 20 machines? And some of them are working well, and some of them are not. And I'm trying to find out what's the same between them and what's not the same between them, and try and help drill down into that problem. And I'm using our standard notebook, but I need to now run it across all these machines. So in this notebook that I've got here available for you, for you to get your head around this is all kind of, this thing, the BP check, it's from the Tiger team at Microsoft. It's the kind of thing you can feel confident to pull down, run, obviously take a look at it, it's code off the internet, but then run it against your machines, and it will give you good information back. So running it against one machine, okay, I can do that. But there's also this command that comes in PowerShell that came out actually 2 years ago now, called Invoke SQL Notebook. Invoke SQL Notebook is very powerful because it allows you to, first off, notebook. right? 2, it allows you to gather that information back and store it in the results file that basically clones the notebook. So first thing it would do is take this notebook here on the right, and it would make a copy of it and then run all those 30 some odd queries and then start sticking the results into that file. And then I have my master copy that I have not changed. And then I've got this one with all the information in it, and it's ready for me to be able to go back to the next time I need to use it. In addition to just doing it on, executing and getting the results, I can also get results from multiple machines if I so desire. And I've just stepped you through here in a quick, easy way of how to do it. So in this one, I'm actually just showing you, hopefully folks are familiar with registered servers or central management server in SQL Server Management Studio. It's a way to just have a list of your SQL servers that are all around. And this step just goes through and make sure that you have connectivity to each one of the machines that are in your registered servers file. And once you've verified that, you can even go so far as to get the database of them if you want to check down at that level. Once you are sure that you've got your connectivity up and running, you can run this in invoke SQL Notebook command, and you can run that BP check. And you can, let me just make those screen size or text size a little larger for everyone. You can run that BP check and have it do this out file and place this wherever you want. Give it a name with whatever you want. I would, recommend possibly putting in the server name if you're doing SQL servers, putting in the date because, hey, you might come back and run this a week from now. And then it would be able to run and save all those outputs for you for all your SQL servers. So in this demo, I've got, my 4 little SQL servers here, and I run it across all of them, and I get the responses back from all of them, and I've got these 4 separate files. And now I can start comparing them and seeing, take a look at the ones that are having problems and see what's difference between them and the ones that aren't having problems. And the great thing is, this can happen, you're executing this notebook when you run into the problem, because we all know that sometimes problems happen, and then as you're gathering the information, the problem goes away, and now you can't reproduce it, right? And you got to wait till the next time it happens to try to capture it again. And that's a great thing about doing this automated troubleshooting here, is that you can run the notebooks all at once, get all those results back, and then start poring over the numbers later and looking through things, or maybe not even later, during, but you've already captured the information and you're already retaining it. So that's one of the examples that I've got for you guys here. And that's one approach to it. Another approach that you can do is just maybe you're helping someone set something up, and it might be to set up something even just to, it might be something as simple as you need to be able to recreate, stand up this environment for this tool that you guys don't always use, but sometimes you do, and not everyone remembers how to do it. So the great way to take that knowledge, stick it into a notebook with all the steps, and then when the next time you have to run back to it, you've got it all right there. Let me show you one of those examples real quick. So just as a basic example, I've got this PowerShell notebook. It is here just to stand up a SQL server and restore some databases. So if you want to think of this, how would this apply to your environment? Maybe you need to restore the database and maybe stand up an instance, restore the database and run some cleansing, or run a load test against it and then try and run your app against it, or do something else and maybe recreate a problem, right? Or go in there to solve the problem or improve performance. So what this does is it goes through and it sets up my SQL server for me and does all the stuff that I need to worry about and gets everything up and running. Again, including restoring my database so that I can go ahead and start working with it right away and putting everything in its place. And I can go on from here and add credentials and add additional information if I so desire. And what's awesome about this is one of the different aspects of notebooks that I want to make sure people are aware is available to them right now is that these things are automatable. in this case, sorry, I'm kind of resizing my machine. I'm working with this notebook over here on the right-hand side of my screen, right? And I want to go ahead and do that action where I go ahead and create a new SQL Server, right? So I want to do all the steps that are inside of there. And the thing is, when I create a SQL Server, I need to give it a password. And in this case, I'm going to give it a port number. I might need to give it a name. I might need to give it something else to go ahead and make it work for my environment. So I'm going to pass in these parameters into the notebook as I go and execute it. And I'm going to go ahead and kick this off so it can go ahead and start running here for a minute. Hopefully everything works out. And let me tell you about it now. So this one comes from a module called PowerShell Notebook. And it is originally started from a guy named Doug Fink, helped out with James O'Neill and actually some of my code that I did and some other Microsoft SQL team members. And didn't work this time. It worked earlier today. It's been a hit or miss lately. I installed the new version of Docker Desktop, and it has been slightly more problematic. But I did run this earlier today, so I already have one running. Let me see. And yeah, and it actually is up and running, but maybe my machine's just running slower because I'm sharing video, and so I need to increase those sleep timers. But anyways, it's up and it really is up and running, and I've gotten the other one from earlier today when I did it. So to be able to do this kind of thing, first you would need to install module PowerShell Notebook, and it comes with this invoke execute notebook command that allows you to take a PowerShell notebook, only works on PowerShell notebooks, but works very wonderfully, and allows you to go ahead and pass parameters into the notebook as you execute them. And it also allows you to, again, save a copy of the notebook as you execute them. And another cool thing that allows you to do is convert your files over to notebooks. So earlier, while Julie was speaking, I went ahead and, oops, I spelled. I went ahead and took my list of commands that I'm working with here, and I just went through and did a quick, where is it? There it is. I took this PS1 file and I just said, go ahead and grab it and convert it to a PowerShell notebook. And now I've got it available over here. And so I've just converted all that PowerShell code that I was working with here. Now I've got it over here, and now I can save it. Now I've got my executable notebook. So that's another part of the PowerShell notebook module. And then one last way of approaching these notebooks that I want to show you, besides the fact that you can pass parameters to them, terrific, makes them extremely useful, and it makes it a lot more. I know I'm doing a very basic SA password, but there are more advanced ways of storing those passwords. That's working, this example, I'm doing things on-prem here on my local machine, but I can also be interacting with the cloud when I work with these PowerShell notebooks or SQL notebooks. So to give you a quick example of that, I'm actually going ahead and use the Power BI commandlet to log into my Power BI tenant. And I've got another notebook that I want to show you real quick. Just one moment while I pull that up. And it is this export Power BI assets. Just one example. It's a data governance example. It marries up with pulling the log file information in case I need to pull the logs out of the tenant and see what's going on, and then marry that data up. I've already got a PowerShell notebook that does all this for me. And what's beautiful about this is I'm able to grab everything, and in this case, I'm saving my results to Excel, and then I pull it back into a Power BI Power BI report file, and then reviewing the information to analyze it. But I've got all these steps all defined, well-defined, and everything is taken care of. I can run it myself. I can hand it off to someone else to run it. And it is, going to always be able to capture the stuff that is important and capture it right away. And if there's someone running into an issue, I can put in those comments of, here's a couple checks that you might want to look into. So let me just close this one down, give us a little more screen real estate. We'll have a little less going on here. So when I do that, I've got one that's specifically for the notebook automation. And I've already, in this case, like I said, logged in. And now I just want to go ahead and execute that notebook. And since I've already logged into my tenant, it's going to have that information cached, and it's going to be able to connect to my Power BI tenant, get all the stuff out of my cloud, and be able to organize that information for me. And I'll just go ahead and kick that off here right now. And again, this is using that invoke execute notebook out of the PowerShell notebook module. And that'll take a minute to come down. And I'll just go ahead and show you where oops, not that one. This one, right over here. Here's the Excel file where I'm exporting it. You can see it's got today's date, just finished happening right now. Pulled this information down. Now, obviously, I don't have to bring it down to Excel, right? I'm connected to the cloud. I could go ahead and be saving this to an Azure SQL database or something like that, maybe a blob store, whatever I need. And it has just taken all this catalog of information, brought it down for me, and now I'm ready to marry it up and put it into my troubleshooting guide to go from here. So the ability to go ahead and connect to the cloud with these notebooks is extremely important to call out. If you see the Invoke SQL Notebook help, so going back to the SQL notebooks, we are able to use the Connect AZ account, grab an access token, and actually pass that in as one of the parameters to the Invoke SQL Notebook command. That way we can run that same notebook up against maybe an Azure SQL VM and run all the code, run all the queries, get all the results, store them back into wherever our notebook file is going to be, and it's ready to go. So those are the main three different ways of approaching notebooks. Just your troubleshooting guide, then your troubleshooting guide with maybe parameters, and then also gathering up your information from your tenant and storing it, whether that's back on-prem for a little bit of just in-depth diagnostics on your machine, or redirecting that information straight out to an Azure SQL database. All of those options are available to you. And that's the quick high-level run-through. And the last thing on troubleshooting I do want to call out is that there is a SQL assessments notebook that can do some great in-depth information checking, very similar to the best practices check, but allows you to target down to just one check so that you could take one of those checks and run it against all your SQL servers. And one of my favorites out of there is actually, there's a check that just checks to see do you have the latest cumulative update. That's something that Bob Ward was talking about in the last session. And you're able to just take that information and, take that command, run it across all your SQL servers and get it all back into one spot, and then see which ones you need to patch, or maybe you're all up to date and you're good to go and you don't have to patch anything, which would be great. So that is my quick and dirty, fast around the world tour of the mechanics of troubleshooting guides and T-SQL notebooks, PowerShell notebooks, and how you can work on automating them in your environment.
Super cool. Thank you, Erin. So I'm gonna steal the screen a little bit here. Just a moment. Okay. All right. So I've been answering some of the questions on the chat. So that was really good question. So thank you, Erin, for the demo. So let's kind of recap a little bit about what you've seen earlier. So earlier we've talked about text cells, code cells, and the different languages that you can use. And there's this new concept of Jupyter Book, which I haven't talked about before, but it's a good way of organizing your notebooks together. And Yeah, so this is a quick example of I think this is a little bit more on the data analysis kind of example. But there was one question earlier: Can you do charting in SQL Notebook? And the answer is yes, you can. So this is an example. If we have time, I'll be happy to demo that live. So, and a couple of you also asked on the chat as well. So is Azure Data Studio free? And the answer is free, yes. And it supports multiple data platforms. So if you have Postgres, Azure SQL Edge, Azure SQL, Azure Data Explorer, if you have your instances, SQL Server instances on-prem, or perhaps in some other kind of cloud providers, you can also connect to them. You can use it on Linux, Mac OS. And because it's a fork of VS Code, we have this shared we have this kind of extensible framework. Essentially, you can create an extension to Azure Data Studio should you decide if it makes more sense to customize, some of the experiences in your way. So we do have a couple of folks in the community that do that, as well as ISVs as an example. So that's really good. On top of that, it supports Git. So when you think about it, and I kind of want to drill into the Git a little bit more here. If your troubleshooting guide currently today resides in something like Word document, or maybe somewhere on kind of like a OneNote as an example, the challenge with that is it may get out of date, and there is also no version control. So you don't have this rigor of software engineering practices applied to your code or your documentation for troubleshooting guides. So like Erin mentioned earlier, notebooks in Azure Data Studio is actually essentially using the Jupyter Notebooks standard. So it's just that in Azure Data Studio, we customize it to make it much richer, much better for data professionals. So as an example, some of the key ones that we actually recently pushed was that WYSIWYG or the rich text editing. In most of the Jupyter Notebook editor out there, normally you would have to write Markdown, but in Azure Data Studio, you don't have to. That way, the jump start is actually quite easy. All right. Okay. So we talked about executable TSGs. Erin has demoed it. Now, I want to draw back to the troubleshooting guides and the incident response challenges a little bit here. Now, in most cases, if your organization, if your teams are super organized, hopefully the troubleshooting guides are actually residing in a central location. But it so turns out whenever we talk to the folks in the community, in the data community, we heard quite a lot of, oh yeah, it's the cheat sheet or the troubleshooting guides or the knowledge base is actually stored on OneNote. And then there's usually code snippets here and there. I usually copy it and then put it locally in my machine so that if a similar issue happen again, I just have to open it from my machine. So essentially you have your siloed environment or siloed troubleshooting guides sitting in your closet, which makes it hard to discover. Sharing code is hard. And it's also hard to crowdsource. So some of the examples that Erin and I have showed earlier, related to the Tiger Toolbox, the SQL Assessment Toolkit, and more, they are actually available online, which means if people want to help improve it, they can, right? So that's one of the advantage of having troubleshooting guides in a version controlled manner, or if possible, publish it on GitHub. Okay, all right. So let me jump a little bit here. Now, you actually have seen this before, but I really want to instill it just for today, for the next couple of minutes here. When you think about notebooks, chances are you probably have seen this before. Like it looks a little bit similar to your past school science projects. And when you do your science project, you usually have this kind of scientific method paper that you have to fill in. And when you write your troubleshooting guides, I think it's actually really useful to think about it in that way as well. Some folks separate the hypothesis and the symptoms steps, I suppose, in one notebook, and then some folks, put the mitigation in separate notebook as an example. So the first part is usually the TSG or the playbook, and then the latter part is the runbook or the standard operating procedure. So yeah, so there's a lot of different ways of capturing the essence of troubleshooting guides in a more structured way. And it's something for you and the team to discuss, like what's the best troubleshooting guide template that you want to adopt in your team. So I've showed you earlier a pretty simple one. And yeah, just experiment, learn it from the team, and hopefully you'll get to a point where you're happy with a more structured, well-written and tested troubleshooting guides. All right, let's see. We do have about 9 minutes, so maybe I'll show you a couple of TSGs, additional TSGs that have been done by the SQL community. So let me do that real quick. All right. There are actually three that I could have shown you, but we'll see how it goes in terms of time, right? So the first one, if you're already in Azure Data Studio, you could do Control-Shift-P, and then you will be able to see a couple of options. So when you type in SQL Server, the Jupyter Book SQL Server 2019 guide, that's available for you to use. It comes with Azure Data Studio, and it will show as provided books here. Now this is Troubleshooting Guides for SQL Server 2019 Big Data Cluster. So if you went to Bugwoody's presentation earlier this morning and you really love or wanting to try BDC or Big Data Clusters, so this is one of the ways of troubleshooting BDC. So as you can see on the left here, it's a little bit more organized, where there's like section, like this book sections, and then the notebooks, the individual notebooks. So that's pretty cool. And you can navigate from one notebook to the other. Okay, and then there's another way of using other people's notebook too. So earlier I showed you how to copy and paste the role from GitHub to and open it in Azure Data Studio. There's another way, and this is the extension way. A person by the name of Emmanuel Manso, he actually published a SQL Server Diagnostic Book extension. So he really wanted to share this collection of notebooks, and I happen to have it installed. So what that really means is when I go Control-Shift-P rather, I can now launch book SQL Server Diagnostic Book. And here it is. It's yet another book, and it's got a lot of useful scripts. So for example, Glenn Berry's diagnostic scripts are here, and there's also more. Let's see. The SQL Assessment API, that's one of the examples that Erin briefly mentioned, and some of the Tiger Toolbox. So it's kind of like if you have to train somebody, or if you are starting as a DBA and wanting to, troubleshoot or have some kind of like already working troubleshooting guides, this could be one of the ways for you to get started. So the SQL Server Diagnostic Book. So a shout out to Emmanuel here. All right. Okay, let's see where we are at with the PowerPoint. Okay, all right, jumpstart your notebooks. On the chat on YouTube, actually, I've shared a PowerShell notebook commandlet or link to the PowerShell notebook where you can learn more about it. So Doug Fink, I mentioned that before, has already written a number of useful commandlets in PowerShell for you to get started with converting your notebook. So if you decide to convert it in batch, I would definitely recommend using the Convert to SQL notebook or Convert to PowerShell notebook. But if you want to do one by one, and then there's definitely an export to notebook UI in Azure Data Studio. So let me show you what that looks like briefly. Let's say, let's create a new file here. So if I have, let me just save it. Yep. Let's save it in my documents, maybe. SQL test.sql. Then save it as all files and save. Okay, so if I start typing select top 10 stuff from sys, text like this, and then put something like hello world. Now I can click and say export as notebook, and it becomes a notebook. So that's a quick way of converting from SQL to notebook really easily, which is really useful.
Right. So if your troubleshooting guide is currently maybe not in a OneNote file, but in a big long SQL file that has a lot of comments in it, you don't want to sit there one by one copying the comments over into text cells and the T-SQL into code cells. You can just hit this button and it'll go through there and take care of that all for you. We've tested up to about 2,000 to 3,000 lines of code. If you get past 3,000 lines of code, you might want to split it up into multiple files, but works pretty well. It saves you a lot of time.
Yeah. So with a lot of these things, tooling help you to get started. Always audit your the outcome as well, by the way. Yeah. So thank you, Erin. It was a fun project to work with you on that, actually. So
that was a blast.
Yeah. So a couple of quick tips. This is summarizing some of the things that I actually already mentioned, but I just want to remind you, there are ways of organizing your notebooks to Jupyter Books. I gave you an example of good or great Jupyter Books. I didn't show you the steps. That's probably for another session. Use Azure Data Studio because in most cases for data, especially SQL professionals, Azure Data Studio tailored that Jupyter Notebook experience for you there. And check out the executable THs for inspiration. So for example, the ones that I've shown you earlier, and pilot, learn, and iterate with your team. Okay, so you're probably where to go from here. Like, what could be possible with this executable TSG framework? This is what I'm envisaging, that teams around the world, you can do this too. Because actually, internally, this is one of the projects that I'm working on to make sure that it is possible to do a system like this, where you have an automated incident response flow. You use notebooks to identify problems or issues, and then you mitigate it. Hopefully, some mitigation may be automated too. And there's some kind of auditing aspect of incident response as part of this execution. And now we're really applying software engineering practices to troubleshooting guides. So hopefully on calls and incident response is not one of those boring or stressful work. Hopefully it becomes more fun. You can bring your software engineering practices to incident response. All right, some of the takeaways. So notebooks are useful apparently for ops, because we have seen and we have talked to a number of folks in the community, and it looks like this is a really promising. Internally, we're actually using this myself for the team, for my team. And data community is definitely embracing notebooks more and more. Use Jumpstart your notebook conversion with some of the toolings that are available. Help the community as well to make the tooling better too. And some of the examples that are available out there are SQL Server 2019 BTC, as well as the Diagnostic Queries book from Glenn Berry. Yes, he has converted, I think, if I remember, all of his Diagnostic Queries SQL scripts to notebooks. So that's really awesome. And yeah, so Azure Data Studio is the best way to provide you with modern data experiences, including, from development all the way to troubleshooting. And speaking of development, Drew is coming up next to talk more about the SQL database projects. With that, please take time to take a screenshot. Here is the wonderful list of resources. And follow myself, MS SQL Girl, on Twitter, and SQL Variant Erin Nelson. We usually post a lot of useful tips there too.
Yep. All right. Good stuff.
Okay.
All right. So that was a pretty interesting session, and a lot of new stuff learning there. But when I was looking at your session, and when you guys showed that you can go ahead and you have kernel option, where you can go ahead and also select Python. That puts me in dilemma. And then I go ahead and check on the marketplace of Visual Studio, where we use Jupyter plugin, right, for the data science purpose. But you tell me that Azure Data Studio also have a kernel for Python. So how does that make sense? So it means if I have Azure Data Studio, if I go to terminal and write pip install numpy, and I create a cell and write use numpy as np, will that run?
It should be, yeah.
Yep.
Because it is a Python kernel, right? And if I have installed it actually run.
Yep.
Yeah.
Well,
So
Yeah, on the PowerShell side, it's very similarly, I install the modules inside of the notebook run space. So exact same thing. Yeah, and that if you're using the PowerShell one, the one that's just PowerShell, not PowerShell.net, it is actually Python behind the scenes as well. So yeah, Python all the way around.
Yeah, I did it. Yeah, I should go back and try it, because in that case, I'm going to uninstall that extension if I need that.
Also, a quick tip as well, if you're new to Python, like I was a couple of years ago, it was a little bit tricky to understand like all these packages, all these dependencies, right? Azure Data Studio, if you do actually have the notebooks up and running and use Python kernel and you're kind of new to how do I install these packages, etc., there is a UI toggle on the right side where you can actually install using the graphical user interface rather than having to know the pip install commands, etc. So that has been very helpful. Yeah.
Okay, that sounds pretty cool. And I think that since you said it's the fork of the actual Jupyter notebook, so it definitely has all the features that the classic notebook has, right? So all the features that you not only mark down and text, you can also go ahead and write in HTML. You can run all the previous code cells, above code cells, so all those things that are available for all the Python data science guys do. This also available for SQL guys, right?
Right. Most of the user interface most of the user interface sort of buttons should be there, but there are some that we are still working on to add more and more into it. Yeah.
Okay. One last quick question. I'm just curious, right? So in Jupyter Notebook, what we usually do is that if we have some variables declared, we can go ahead and check their values at a certain stage, right? We have a variable explorer. So does this Azure Data Studio also has it? Because why do you guys need it? I mean, just curious.
Right. I'm glad you asked, because this is probably a good time for me to advertise as well. Since it's open source, if there are specific features that you want us to add, please do. I've just posted on the YouTube. So if you go to the GitHub Microsoft Azure Data Studio, you should be able to check if there are existing issues and vote for it, because we do triage it and decide what should we do next. So Variable Explorer is super important. So hopefully we'll get that in very soon. Yeah, but it's not there today, unfortunately. Yeah.
Yep. I use notebooks in my daily work at Microsoft, and that's something that I am in need of. So I'm asking for it too.
Yeah. So we're very grateful for our supporting fans and users as well, like Erin as an example, internally as well as externally too. So it's been a blast for me as a program manager in the team, because I get to work with very, very passionate people in terms of how to make notebooks more applicable to their daily job. So thank you for having Erin and me. It's been a blast. Thank you.
Yeah, we will. I mean, go ahead and check this comment. Office integration. That's a long shot.
Yeah, talk to them. Talk to that team, not us.
If you want it, ask for it on the GitHub. You never know.
At least you can run CSV files until in the notebooks. That's all. Yeah, you can definitely do. So thank you, Julie, and thank you, Erin. Thank you so much for your time. Thanks for all that you do for the community, and especially thank you for supporting the cause too. That's really important, and it was a really great session. I loved it, and I think there you go. Azure SQL says. Julie and Aaron. That's good. So thank you so much, Julie and Aaron. Now we'll move to the next session, and have a great weekend ahead. Thank you so much. Bye.
All right. Thanks.
Bye. Thanks, Simon. Thanks.
Yep.
All right. So that was such an interesting session. Now it looks like SQL guys love a lot about notebooks, and let's go ahead and move to our next session that is about SQL project for database development. That will be by Drew. So let's go ahead and invite our next speaker, Drew. There we go now. Hi, Drew. How are you?
I'm great. How are you?
Good. Thank you. Thank you so much for your time. Thank you so much for being a part of this conference. And Yeah, I'm really looking forward to your session. SQL project for database development. Even Julie and Aaron were really excited for your session. So are we, and I think we have already taken your 6 minutes. So I'll quickly allow you to go ahead and share your screen and get started.
All right. Let's see here. So I think that was such an excellent note that the notebook session ended on, talking about how Azure Data Studio is open source and we're always welcoming feature requests, because SQL projects was one of the first really big feature requests that came in for Azure Data Studio. And so it's been really exciting as a program manager at Microsoft to be adding SQL projects into Azure Data Studio over the last 6 to 9 months is when it's arrived. So that's what we're going to talk about.
Right, so I'm going to put your screen in the stream, and next 45 minutes is all yours.
Thank you. This is going to be a blast. I am Drew Squires-Cabala, Program Manager at Microsoft, and those two links there are the documentation for SQL projects, as well as a code repository that has examples kind of across this whole presentation. There's a lot of content when you talk about development with Microsoft SQL, whether it's SQL Server or Azure SQL. So full disclosure, this last item, we don't have time to cover for it. But if you are a developer and you're intrigued by developing with SQL Server Containers, check out that repository, because there's some really cool stuff you can do. We're going to focus our time on SQL projects and how that works within Azure Data Studio. Before I can dive into SQL projects, though, I need to kind of talk for a moment about why do SQL projects matter? Why can't you just write SQL code and call it a day? And that comes down to the artifacts that we need, the master files that are required for deploying database changes. As a developer, as many of you are, you've got a kind of a familiar development pathway. You write the code, whether it's in VS Code or Visual Studio or completely different IDE, and then that code is compiled, it's validated, you're likely writing tests, there are code reviews, and then finally that code is deployed. This process repeats for different features and bug fixes. They do happen, but it's fairly universal. Things get interesting when you talk about databases. The complication with databases is that instead of just being code, instead of just being create table statements, create stored procedure, you have data. That database that's a part of your application has a state associated with it. And so data tier application artifacts, the two primary ones, a DAC pack and a backpack, help us kind of keep that under control. The DAC pack is just the schema, just those objects. So if you have a really large database with a bunch of data in it, the DAC pack itself is going to be quite a bit smaller because it's just the schema. It could be thousands of tables still, but the data is not included. The backpack, however, is a snapshot of the entire database, including the data. So let's tie this back into that development process, that pathway. Declarative database development takes those data tier application artifacts and integrates them by having us develop for databases by focusing on what do we want the database to look like? What's that end state? So you've already created a table. You do not have to worry about writing an alter table statement. It's just You write the create table statement for the table that you want. This is also called state-based development because it's just a final state. The tooling that you use has to manage the change or the migration during deployment. So you develop with T-SQL or with a table designer that spits out that T-SQL for you. Then the tooling builds it into a DAC file. So not unlike you would build and compile a project in .NET, that DAC is built. And then finally, the tools that you used then take that DAC and update the database's state to match that schema. And the DAC file is that what we need. At a really fundamental level, there's a command line tool that works with these data tier artifacts, and that's SQL package. It's cross-platform and available whether or not you're on Windows or Linux or Mac OS. So this is a really popular tool to use in like DevOps pipelines because it allows us to work with data tier application files. And so I was talking about the publish operation. That's that incremental change that updates an existing database or creates a new one with the schema from the DAC that you've created in your development. And that could be to a SQL Server, whether it's on-prem or in the cloud, or to Azure SQL in one of those databases. But SQL package is quite versatile and very functional in that has operations for backpacks and DAC. So if you are needing to orchestrate data application movement, then that's when you've got the tool for SQL package in terms of scripting this thing out. The syntax for SQL package is straightforward, but it's great to understand the one variable you want to watch for is the action, because that determines whether or not you're doing extract or publish or import or export or one of the others. And then from there are different parameters and properties, lots of them, that allow you to fine tune that process. I see a couple of questions in the chat. Is there active updates to SQL package? Absolutely. SQL package gets updated roughly quarterly. There is active development to it. I would say you can expect to see an update to it within a month and a half now. And then a question from Paul on deploying file stream and memory optimized structures. Paul, I do not know that off the top of my head, but I am making a mental note and I'm going to see if I can find that out and reach out and get back to you. So we've got SQL patches that allows us to work with these data tier artifacts. Over the last, I would say, year and a half, 2 years, there's been more frequent updates to it. There was a period of time where there was a lot of work happening under the covers. And what that work was bringing it to .NET Core so that it could be cross-platform. And why do we care that it's cross-platform? Because the fundamentals within SQL package work with database projects, which we've known and loved in SQL Server Data Tools in Visual Studio for years now. If you're using Visual Studio 2019, it's the data platform workload. And that gives you this declarative database lifecycle for your database applications. Back in September of 2020, we added the SQL Database Projects extension to Azure Data Studio. This means that if you are on Windows or Mac OS or Linux, you can use Azure Data Studio free open source, and work with SQL projects. It's going to use the .NET Core SDK to handle the build operations right there in the UI, and as well as that .NET Core SQL package. So we have that now available, and slideshows are fun and all, but I want to go ahead and dive right into working with database projects in Azure Data Studio. We're going to take a look at an example where you can create projects either from scratch, or you can grab an existing database and work with that. So we'll do that. We're going to make some changes to our database. We're going to be able to build it, look at what the deployment process look like. We're going to use some functionality from database projects known as post-deployment scripts. A post-deployment script gives you the opportunity to run additional T-SQL following the original deployment to do things like modifying additional permissions or inserting some static data. There are two other extensions in Azure Data Studio that are really complementary to database projects. The first is the data tier application wizard that gives you a UI on top of SQL package. And the second is schema compare, which allows you to look at the file differences between databases, between DAC packs, between a DAC pack and a database. And we'll just take a look at that as well. So let's have some fun. I am switching over into Azure Data Studio. And I have a database. It's an AdventureWorks 2019 in Azure SQL. Since I've installed the SQL Database Projects extension, I have the projects pane. But even from within the Object Explorer, I can grab a database and say, I need to create a project from the database. And it's going to give me the options of the server and the database, but it's also asking me where I want to put it. These are going to be all the scripts that define the schema, the tables, the procedures of this database. So I've got a folder for this, and you can have it pre-organize the files for you. I am going to just use straight up object type and hit create. So Azure Data Studio is running a process in the background to grab the scripts for all the tables and the views, and it's going to pop us into the projects pane to basically open up this SQL project. I missed a really important point when I was talking about Visual Studio earlier. The current SQL projects in Visual Studio, you're already working in them. That's fantastic, but you want to give Azure Data Studio a try. They're compatible. So if you are collaborating with others and using different applications, there's cross-compatibility there as well. We have our project. We've got the tables and the functions. So for example, we've got a customer table here. This is the customer table definition from the database that I just grabbed out. Now, we've got our scripts. That's great. But let's take a look at some of the functionality of the what now. If you are ready to build your changes, let's say we want a DAC pack from this, we'd hit build. When we're ready to publish this out, let's say that we don't have a pipeline that publishes our DAC pack for us. We've got permissions. We can do that directly from here, as well as a tie-in directly to schema compare. You can be adding additional objects, including a post and pre-deployment scripts, as well as some ways to get a little bit under the covers. Changing the target platform, for example, allows us to say, I've exported a database from SQL Server 2014, but I'm ready to deploy this onto SQL Server 2019. Or perhaps you've exported it from 2014 and you'd like to use some of the functionality added in SQL Server 2019. When you do the build process, it's going to validate the code that you've used against that engine. So if you're using things that are only available in SQL Server 2019, you're going to need to make sure that your target platform matches that feature set. For those of you that I mentioned already work with SQL projects quite a bit, you do have direct access to edit the SQL project file if you want to get really hands-on. The schema compare is the most complementary other extension, and database projects will prompt you to work with it. The other one is the SQL Server DAC extension. And this gives you a nice wizard interface on top of SQL package. So if you're not a fan of command line, or for some simple operations you'd like to be able to go through the wizard, I do highly recommend this extension. But let's work with our project here. I am going to add a column to our customer table just for our rewards account ID. And I'll make that. And I've saved the file, but this has effectively added a column. When I build, it's going to go ahead and use the .NET SDK here, and it's going to build a DAC pack. When I stored the project on my local machine, it's going to build and place the DAC pack in a similar folder in there. So if you're interested in manually grabbing that DAC pack, it has built successfully, and the DAC pack is available in the folder there. But everything that we're doing within Azure Day Studio does not require us to manually grab that. I could do a schema compare now. Let's say I don't remember all of the changes that I've made, and I want to see kind of the difference between the current project, that DAC pack, and a live database. So we'll select a target of a database, and I'll use the database that I pulled this project out of. Before I hit compare, I do want to make sure that I highlight these options. You could have a lot of changes potentially when you're doing a schema compare. So it's nice to be able to filter out or exclude specific objects, or whether you're looking at other options. There's some good ones down here. White space. White space changes, if you want to be able to ignore those, you can make sure that that's checked. But when I hit compare, that's fantastic. We are live. I'm going to give it another go. 1 second. Yep. So comparing to a database. If I hit compare, okay, that's failing. That's okay. So when I do that schema comparison, it gives us this view where you can see the difference between things that have changed. In this example, a secondary phone number column has been added in the project, which is on the left, and on the right, where the live database is, that secondary phone number is not there. If you use source control frequently, this is not a new concept to you. So let's take a look at not only were we able to kind of just modify the schema flat out, but I mentioned earlier those post-deployment scripts. We can add all kinds of new tables, but I wanted to focus on a post-deployment script because it allows us to kind of break out of the mold as we need. So I'm going to say add test customer is my post-deployment script name. And this adds us a extra SQL file into our project. And if I grab some text real quick, I have an insert statement that allows us to add a customer row with my name and a sample password. So if I save this, and let's go ahead and publish it. So I'm going to publish to AdventureWorks. Before I do that, I want to look at one thing. If I select top 1000 from the customer table, looks like my database disconnected. That's okay. We have databases aplenty. Let's take a look at a different server. When in doubt, reboot, except for not all the way when you're in the middle of a presentation. I've reopened Azure Data Studio, and so it's reconnecting to a couple databases. It's going to remember the workspace that I had open. You can combine multiple SQL projects into a single workspace in Azure Data Studio. If you're familiar with Visual Studio, you can combine multiple projects into a solution. That same idea applies to the workspace concept in Azure Data Studio. So when I closed out of impatient irritation and reopened, it remembered that workspace, reopened the workspace, and reloaded that project for us. Looks like my database is back. So we're going to go ahead and connect and run this query. What I wanted to point out is that we don't have a column for rewards account ID in the table. So we're missing that element of the schema that's in our project. Let's also check to see if I'm in here already. I am. I am no longer. We're going to publish our project. when we publish our project, we should expect that the changes that we've made to the schema, namely, we should have a rewards account ID column. We should expect to see this, as well as we have a post-deployment script that should run and do some changes. So we can even have it insert 1 for me and then 2 for Louis back there who's sleeping. We'll save that. So I'm going to publish our project. We're going to check out the result of that. Before I hit publish, I mentioned earlier that we have to let the tools handle that differential between the states of the database. There's an element of trust there, and there's also the expression trust but verify. That's what generate script is great for. The ability to generate the scripts, whether in Azure Data Studio or through SQL package, there are options to do this. We can spit out the scripts that will be applied to publish. So we can inspect those manually and make sure we're okay with the changes. You can assess the risk of the changes. You can decide what kind of impact they might have on production downtime, if it's going to be seconds or minutes, that kind of thing. If I scroll all the way to the bottom, we can see our post-deployment scripts. I trust. I've mostly verified. I'm going to go through with the publish. So we are publishing the project right now. And there's our deployment operation. It should take a few seconds. I'm checking for a few comments. Cool. So we've got our deck pack deployed. When I run select top 100 from sales.customer, I should see a rewards account ID. It's empty. We just changed the schema. We didn't do that. I check for the data added by our post-deployment script. It's there as well. So this gives us kind of the full picture of what happened after the deployment, as well as during the deployment where we got that rewards account ID. So from this SQL project, you have the ability to work with whether it's a create procedure to write procedures. You don't need to worry about create or alter. You write create, and the publish process handles determining whether or not that procedure is already there. So let me make sure I'm not missing anything. So what we have done with our project is that we were able to create a new project by extracting that from a database. We were able to edit it. We did some basic editing, but I'll go back in a minute and show a few tips that I have for kind of working and editing in Azure Data Studio. You're able to build the project right from within Azure Data Studio, and then you're able to publish that project. Some frequent questions that I get come around, can I build from the command line? SQL package does the extract and publish operation, but what about build? That's a very reasonable question. And for that, if you go to aka.ms me grab the full. aka.ms/Azure Data Studio SQL projects. This is the full documentation, but the nugget that I often lead people to is being able to build a project from the command line. After you've built in Azure Data Studio once, some files are placed in your user directory that can be used to then build projects from the command line. So that's one item that I wanted to make sure that you knew about as a frequent question. The other thing about editing in Azure Data Studio that comes up pretty frequently is I was doing some, I will say, low intensity changes. I was adding a column. I wasn't creating a new table from scratch, that kind of thing. But if I say want to add a table, and we're going to call this test table, it gives me a really basic framework. Let's say I want to create an index and the syntax for that escapes me. There are snippets included in Azure Data Studio. So if you start typing SQL, IntelliSense is going to suggest for you some of those snippets, whether they're create index or use a cursor. So if I do SQL index, I'm going to do create index, and this will allow me to define an index a little bit easier than trying to remember the syntax completely from scratch. So that gives us kind of an overview of editing in Azure Data Studio. Azure Data Studio is a great application for kind of a broad set of functionality with SQL Server and Azure SQL. It's gaining new functionality at the time. I swear every single time I see folks' presentations, I see things that we've shipped that I missed because there's so much being added all the time. But for a lot of people, especially developers, they're working in VS Code in their projects, and there is development functionality in VS Code. SQL projects in this form are not there yet, but because Bob Ward talked about SQL containers a bit earlier, I did, since we have a minute, wanted to take a quick detour over to VS Code and talk about container-based development. SQL database projects in Azure Data Studio are continuing to get new functionality. So please, if you have feature requests, drop them on the repo or vote on the ones that are already there. Same thing goes for VS Code and the MS SQL extension for VS Code. It's used for connecting and querying database servers. It has a lot of functionality like the query history. I mentioned that I'm taking this detour because of MS SQL containers, especially as a tool for development. I'm not going to go to bat for them as production tools in this session. Bob's got that covered. But as a development tool, I want to show you something pretty cool. There's something called remote container-based development in VS Code. What that means is that VS Code sets up a container for itself on your local desktop, on your Docker desktop, called the app container. And it connects to that and it runs it processing that. What we can do because of MS SQL containers is really quickly set up SQL Server environments for our development instead of either having to be on a Windows box and or installing a SQL Server locally. We can create that as a part of that development environment. So it becomes a lot more reusable and faster to spin up and spin down. You're no longer worrying about managing containers independently. It becomes a part of developing in VS Code. On top of that, as you automate these development environments, tools like SQL Package can be used. So, bearing with me for a moment, let's say you have a development environment. You're trying to build a .NET Core app. You're C# developers, many of you, not a far-fetched prospect. If you already have a DAC pack built and you put it as a part of your development environment, SQL Package can be used to do that DAC pack deployment as the dev environment spins up. That's the prospect that's in the repository for SQL development I'll show you in a minute. The other side of this coin is that remote development in VS Code is the GitHub Codespaces environment. So yes, what I'm telling you is that not even on your local machine, but in the browser, you can spin up that remote development environment with a SQL Server in there with you. It's kind of like the moment when they're like, they're in the house with you on horror films. Yeah, the SQL Server is right there with you. So as you look at a dev container setup, you would have a part of a Docker Compose add an additional image. So that's the SQL Server latest. And you can set those environment variables that we saw earlier, including accepting the EULA and setting an SA password. I know that's the worst SA password in the world. Bear with me. The other part about automating your development environment that's so important is that you can set up VS Code to be ready for you. And I'm going to demo this here in a second. But you can say, I want these extensions. I need the C# extension, and I need the MS SQL extension. So I can build my .NET Core app, and I can run queries against my development server. You're set. You probably have other extensions that you want, and you can add them to that array there. You can set up the MS SQL extension going into your container. So I can say, I want my local host container. This is the SA password I sent, and it's ready to go. So this instance of VS Code, it has that Docker Compose that not only has the app file, but the database file. This is already completely set up for me. That seems too easy. I know Bob said that he challenged someone to get set up with SQL Server development on a Mac in 5 minutes, and they did it in 3. Let's see how we do. I'm in VS Code. The only thing that I need to make sure that I have, besides Docker on my computer, is the remote containers extension. I am going to add development container files. I have to open a folder first. Let's open a folder. So I've got a folder, it's opening, and then it's gonna ask me what What dev container do I want to add? I search for SQL. There's a C#, .NET, and MS SQL definition. Huh, look at that. It's going to bring in a kind of bare bones setup for us. You can learn more about it at the link right here. But VS Code says, wait a minute, I see a dev container definition. Do you want me to spin up that container and reopen? So I'm going to hit reopen. VS Code is going to handle the Docker pull for the SQL Server. It's going to reopen itself in that app environment with .NET Core so I can do my app development. VS Code is going to install the MS SQL extension for me because it knows that it's this really amazing tool. And then we'll be able to use the MS SQL extension to connect to our container. So we have two complementary applications. We've got Azure Data Studio, where we can do kind of focused SQL project development. We can build those SQL projects into our DAC pack, our data tier application files. And then we also have VS Code, which is complementary, a development environment where we have got some really essential SQL tools that we can tie right into modern development concepts like containers. So VS Code is starting the container and it's opening the remote. And while I give it a moment to do that, this repo right here, github.com/daisy2/SQL development tools, has info about database projects in Azure Data Studio, and it has information about the dev containers in VS Code. We definitely don't have time to go this far down the road, but I can tell you that if you fork that SQL development tools repository and you open in code spaces, you can get that same VS Code development environment right in your browser. So this is the code spaces version, whereas my dev container is installing the extensions, opening the remote, connecting. Still got my dev container definition. I'm in the remote now. It's installed the MS SQL extension. It's going to grab the tools service, and then it's going to have that connection pre-populated for us. When we look at database development, I started at the beginning and I said there's kind of a hitch to database development. We have to keep in mind that there's a database state. But with the proper tools, you can still use the same development cycles that you use for building C# applications. So I do suggest that you check out the database projects extension in Azure Data Studio, especially if you're using SSDT, because they can be really complementary experiences, especially if you're collaborating with other people. Different people may be using different tools. And then with container-based development, you get a really reusable environment. So in this example, we've got this MS SQL container where we can create databases. And in the example in that GitHub repo, there is a script that runs as the container launches that looks for DAC pack files and then publishes them in the container when the container spins up. So instead of hopping into this empty environment, you can throw a DAC pack in there and hop into your app's database and get right to work with your C# code or your Node.js code or whatever you truly care about. I have some follow-up to do with Paul on a question about memory optimized objects. You all are welcome to reach out to me either via email or on Twitter. And here are some resources to help you go after some of the cool tools that we looked at. Thanks for joining me today. That's all I have.
All right, dude, that was great. I think this is the first time I attended any of this SQL project, what do you call it? SQL project session, and this looks pretty interesting. And I've not seen many people doing session on it, so I think we should do a little more.
Awesome.
All right, so dude, thank you so much, dude. Thank you so much for your time. It was a great session. We definitely get to learn a lot, and definitely we're gonna take all these sessions and add the watch single so that people can always come back and watch it. Thank you so much for all that you do for the community. And while we were making a video, I think you really love dogs.
This is true. This is true. Thanks for having me, Simon. This has been fun.
Thank you so much, dude. See you soon. Bye. Have a good weekend. All right, so we are done with session number 11, and now we move to session number 12, and that's on Learn Azure SQL Database through demos, and that's gonna be by a community rockstar in the SQL community. So smash that like and keep the comments coming in, because we now have Anna Hoffman. Hi, Anna. Welcome to the SQL Server Conference.
Hi, Simon. Thanks for having me. I love that video. I always love seeing it. Makes me look
like,
so cool.
Yeah, that that upbeat music, dim dim dim. That I love that too.
Gets me going.
Yeah, look at you branded again. What are you wearing today?
Oh yeah, today I'm wearing my C# Live shirt. Or does it say C# Corner?
Oh, yeah, that's
Simon,
good.
you sent me so much cool stuff.
We're not gonna send you this time. I mean, for this conference, we're gonna reserve it. We're gonna reserve it for April, right? You can get that.
Makes sense.
Yeah,
I'm excited to be here. Thanks for having me.
Yeah, and I'm really excited too, and I won't take much of your time. I think we're only 4 minutes above it, right? So already see your screens. I'm gonna put it under the stream, and let me go ahead and change the background. So next 40-45 minutes is all yours, and I'll catch you after your session.
Awesome. Thanks so much, Simon. Hi, everyone. I'm really excited to be here. I have a lot to get through today, and I have 0 slides. So this is the closest thing to a slide you're going to see. I thought I'd try something new. So for better or for worse, I've never done this before. What we're going to do is we're going to do a session all about Azure SQL Database with no slides. So we're going to walk through deploy and configure, and then we're going to go through security, performance, and availability. And I'm going to give you all the resources, mainly these 2 resources at the bottom, so that you can actually go do every single one of the demos I'm doing today in your own environment for free using Microsoft Learn. So if you look here, what you're seeing is Microsoft Learn. This is a learning path that Bob Ward and I created last year. We actually just updated it, so you can be sure we're always keeping it up to date. But this is basically Azure SQL fundamentals. And so we're going to go through actually a lot of demos, as many demos as I can fit in the time that we have today on these topics. And then you'll have the resources to go do them all yourself. So that being said, we're going to get started right away. So again, this is going to be a fast-paced session. I hope you'll enjoy it. We'll take questions as they come in if we can, or if not, I'll stick around and be sure to answer them on the chat. All right, so the first thing is this is the Azure portal. I think you've been around today, so you've seen this before. What I want to call your attention to is this Azure SQL Blade. Now, if I click Azure SQL, really cool, I'm going to be able to see all my Azure SQL resources in one place. So whether they're databases, got a lot of databases, logical servers, virtual machines, elastic pools, managed instance, all in one place. So that's awesome. Now, what we're going to do today is we're going to focus on SQL database. So you can see I went to the plus sign and I can have some options around what I'm going to create. We're just going to do a single database now, but know that you can explore these other options later. When I hit create, I'm going to be brought to a screen that maybe you all have seen before when you go deploy any resources in Azure. It's going to ask for my subscription, a resource group, a database name. I'm going to call it AdventureWorks, and I'm going to create a new logical server. Oops, new logical server. We're going to call it AW Server 0129 to go with the date. And we'll actually use one I created yesterday, but for deployment purposes, let's deploy a new one. So I'm typing live, and you guys know how that might go, well or not. Nope, didn't go well. Let's try again. All right, and so basically I'm picking the server admin login. So this is basically like the sysadmin for my Azure SQL database logical server. Different from a SQL server, a logical server just manages a lot of the metadata and some of the security things around your Azure SQL databases associated with a logical server. You need something to log into. So I have a username, picked a region, gonna click OK. It's just gonna validate that, and then this should be okay. Yep. There is no database on this server yet, so I think that will be fine. Now, next, I'm going to choose not to use an elastic pool, but an elastic pool is a way to cost optimize and resource share if you have lots of databases. So that is an option here if you want it. But we're going to dive into compute and storage. Now here, there are a lot of options. Try not to get overwhelmed. We're going to walk through just a few of them today. The first is general purpose. If you're familiar with SQL Server, which I'm guessing at this conference you are, this is behind the scenes going to deploy what's very similar to a failover cluster instance. And we're going to see in the availability section that I have today what that kind of looks like and how you can kind of almost tell that when you do something like failover. The other service tier I want to call your attention to is the business critical service tier. Now, behind the scenes, if you want to relate it to SQL Server, when you deploy this tier, we're basically going to deploy an always-on availability group for you, meaning you have 3 secondary replicas at any given time, and one of them we're even going to let you read from. Now, hyperscale is our newest service tier, but even still, it's not that new. And one of the great things about hyperscale is that you can scale up to theoretically as big as you need to. So we support up to 100 terabytes, but in reality, that's just a number. And one of the great things about this is you can kind of deploy secondary replicas as you need them, up to 4 of them, and you can use all of them for readable workloads. So that's really interesting. It's also going to help with failover times, but we'll get to that in the availability section. So let's take a closer look at general purpose. Now, once you've chosen general purpose, you have a few options in here. The first is on compute tier. You can either pick provisioned compute, which is the standard for all these other service tiers. And what provisioned compute means is basically you're saying, okay, I want 2 virtual cores or 2 vCores at any given moment. Whether or not I use them, I'm reserving them, so they're mine. Now, the serverless model is a little different because you're saying, hey, I want, let's say, we want a max of 8 vCores and a min of 1 vCores. And why this is interesting is because serverless is going to take care of scaling you on a per second basis between these min and max based on what you actually need. And we're going to bill you based on what you actually use. So this is a really great way to cost optimize as well. And especially for like dev test workloads or workloads that aren't running all the time, this can be really beneficial. Another reason for that is because you can set an auto pause delay. So in this case, you could set it to 1 hour. So if people aren't using this on the weekends or at night, after 1 hour of inactivity, this is actually going to shut down. We're going to separate the compute from the storage, and will only bill you for the storage. So this can be a way to get great cost savings with serverless. So we'll reference serverless in the performance section as well, but for this, we're just going to use provisioned. All right, so hopefully people are following so far. I'm going to click apply, and I'm going to go to the next blade of deployment. And this is where you're going to select your networking options. Now, the default is no access, and in my experience, unless you're really about to go build something really big and really know what you're doing, then you can use the no access, but it just means you're going to have to configure it later, because what good is a database with no access? Now, the option that I recommend if you're trying to get started and just make things easy as far as connectivity goes is to use the public endpoint. Now, with the public endpoint, you have two additional options. You can opt to allow Azure services and resources access to the server. This is going to basically allow other things in Azure, like Azure Data Factory or Azure Functions, to easily connect or already be accepted to be able to connect to your Azure SQL database server. And then the add current client IP address is basically going to add a firewall rule for wherever I'm deploying from, which is also going to make things easier for me in the future. However, if you want the most secure way of connecting, then you go towards private endpoint. So I want to show you just one example for why I say that. So let's take a look at lots of things to show you all today. Let's take a look at this PowerShell window. So what I'm using here is NSLOOKUP, and this is just a way to look at the publicly available DNS hierarchy for different servers or websites. So I'm pinging a server that is using the public endpoint, okay? So I'm pinging this server. You're always going to get this IP address back from an Azure service. But what I'm also seeing is some information about where this database server is located. So I see control ring 4, East US 2, so that's the region it's in. I'm seeing another public IP address. I'm seeing information about the data slice. So some information that I don't necessarily want to be publicly available. Now, what we can do is if we enable private link, which we will, but I enabled it on one yesterday, the result of that is going to be very different. So what we're seeing now is, of course, we're still seeing this Azure IP address. You're always going to see that for any Azure service. But under this other section, what you're seeing is this alias, which you actually can't connect to, a private IP address, which isn't going to be useful unless you have access to the virtual network that this is in, which is unlikely from a public standpoint, and then just the database again. So this is a much more secure looking DNS hierarchy, which reveals much less sensitive information. So that's one reason you might pick to go towards private endpoint. Now, if you want to set this up, it's really actually not that hard as long as you have all the connectivity things in place, assuming you have that. I have other sessions on that if you want to learn about that. But basically, I'm going to call this AWS Server 0129-PE for private endpoint. Now, you can see this is for a SQL Server resource, but we have private endpoint available for lots of other Azure services. So this is not something that's unique to SQL. It's just great for SQL as well. I'm going to deploy this into a virtual network, actually the same virtual network that my virtual machine is in, so that I can easily connect to it. You can also integrate it with a private DNS zone, hit OK, and you're good to go. So really easy to set up private endpoint as long as you have your connectivity things in place. Now, in additional settings, I have the ability to select a data source. So I can either choose to, not just start with a blank database. I can pick an existing backup that I have from any server that I have access to. And then I can also choose a sample, which is the AdventureWorks sample by default. And this is what I run all my samples on. Everything in Microsoft Learn is around AdventureWorks, so this is going to be great for all the demos. You can see the database collation rule and how it's set because it's already set for this database. And finally, you can configure Azure Defender for SQL. That's something we're going to take a look at in the security part. So remember, we're going to talk about deploy and configure, then security, performance, and availability. So we got a lot to do, and we've done a lot already. So now I can go ahead and click Review and Create, and I can go ahead and start to deploy this. Now we'll see this deploying, and it'll take a little while to deploy, but I wanted to show you one I've already deployed. So this is my resource group of things for today. You can see yesterday on January 28th, I had deployed basically the same thing with the same private endpoint and the same database. So you can see some of those things there. I also configured auditing, but we'll get to that in a bit. All right, so let's talk about connecting to this thing. So I'm going to switch to SSMS, wonderful tool we all know and love. And I'm going to go ahead and click connect so you can see what it was like for me to connect to this. So you can see I just put the full logical server name. And I can choose to connect to Azure Active Directory if I've enabled an Azure Active Directory admin on the server and created those types of users. When I first deployed, I would just connect using my cloud admin account. Since I've already connected, I'm going to close out of that part, but I am going to show you how to create an Azure Active Directory admin. So back in my resource group, I can select the AW Server 0128. And you see a lot of information here, but down on the left side, there's an option for Active Directory admin. And here's where you can see I've set myself as the admin. I'm not going to go into this because it shows a bunch of people's PII or personally identifiable information, but you can see that I've set myself as the admin. One thing to note here is you can only have one. So that's something to keep in mind. It could be a group, but you can only have one kind of account listed here. I also just wanted to touch on the backups, that your backups are taken care of automatically for you just by deploying. I can do point-in-time restore up to 7 days ago, and I can optionally configure long-term retention, whether it's weekly, monthly, or yearly, and see information about the pricing tier. So it's all here. All right, so we talked about a lot of stuff so far. Hopefully it's going okay. Let me see if I can see any comments. Let's see. Yes, this session is going to be a lot of learning. Simon's right. All right, we're going to keep going. So we talked about deploying, configured. Now I want to get into security. So from this logical server, how do you get to the database? You can click SQL databases, and then we can navigate to this database. Again, this is the same database that we basically just deployed. Now we're talking about security now, so I'm going to go down to the left, and you're going to see this security section of items. The first one is auditing, and what I've done is you can enable it on the database level, or you can enable it on the server level. So I enabled it on the server level to point to a storage account, so that's where my XEL files are going to go, or I can connect it to a log analytics account, which I've also set up so I can use Custo query language or KQL to do some querying of auditing and the audit logs and see kind of who's accessed what. This is a really rich tool. I definitely recommend spending some time and learning about it, and I'll share a resource for that. Okay, so since I have auditing set up, I'm going to go back. Oh, let's see, my screen froze. That's unfortunate. Okay, it's okay. We're rolling with it. Maybe. Give me one moment. Never had that happen before. Let me see. 1 second, folks. Let me just get that up. You know, you always see the new things that happen to your demos. They only happen live. Like, I don't think I've had a virtual machine freeze on me in a very long time. But let's see if we can get it back up, and then I will share that out with you all. All right. Just my session expired while I was using it. That's what happened. Okay, let me share that out again. Sorry about that, folks. Hopefully you can see my screen. Awesome. Okay, so back to figuring this out. So we're back in our database looking at the security section. I showed you that we set up auditing at the server level. Now the next option we have is data discovery and classification. Now this is something available for SQL Server on-prem using SSMS, but for Azure SQL Database, it's built right into the portal. We even have automatic recommendations, which I've gone ahead and applied. I want to bring your attention to 2 recommendations. One was customer first name, and it automatically picked this up as name info and confidential GDPR type of sensitivity label. And then we also have the same here for last name. So that's data discovery and classification. Next, I might say, you know, those first name, last name, I also want to mask that data. So what that means is when someone who doesn't have access to view the data sees that data, they're just going to see it as a bunch of X's. And you can see I have other options here around credit card value, email value, or I can even do a custom string type of value. We're going to keep it as the default, and I added those for first name and last name. I also wanted to note before I get into an example that TDE, Transparent Data Encryption, is on by default with service managed keys for Azure SQL Database. But if you want to do bring your own key, you can enable that at the server level. Okay, so let's take a look at a hopefully cool example. I'm going to bring my friend Bob Ward. He gets to be a lot of my demos because, you know, he really likes the Cowboys, so I like to use him in another sense where he likes the Titans, which is who I'm a fan of. Okay, so let's take a look at this table. So I have this table. You can see their first and last names. The reason I can see it is because I'm connected using an admin account. You all noticed I selected myself as the Azure AD admin, and I'm connecting using Azure AD, so I can see this. So what I want to show you is how we can create a new user. So we're going to create a user called Bob with the password called Go Titans. Now, this is a little different from what you may have seen before because I'm actually going to do it in the context of the database. So I'm just going to create him right here. And now, similarly, if I wanted to use Azure AD authentication to add Bob, I could do the same thing, except the new verbiage that you don't have on-prem, I believe you don't, is from external provider. And that's how you're going to add those new Azure AD accounts. Okay, so I'm going to go back here. I'm going to create a user. So this is, you know, just, oh, he already exists, so I'm not going to create him again. And then what I'm going to do is make sure he has access to read and write data. Before you do this, they don't have access to that. It's just like SQL here. Now, Bob doesn't have that many privileges, so he shouldn't be able to see this data that we've added dynamic data masking to. And sure enough, you can see first name, last name are X'd out, and perhaps maybe you would consider saying you should probably track middle name as well, but let's just leave it like this. Now, if for whatever reason I wanted him to be able to see this data, I could use the words grant unmask. So that's basically going to allow him to see this data, and you can see that here. Now he can see it. I'm using these execute as to execute as Bob. Finally, if we decide that Bob no longer needs access to this, or we don't want him to access people's names, I can simply use the revoke unmask. So you have grant unmask and revoke unmask in order to do that. So that's an interesting exercise. Now, since we used the storage account, we can actually merge the audit files and take a look at what we just did. So I'm going to, instead of getting the log files from local like you would with SQL Server, I'm going to get them from that blob storage account that I connected them to. So let's see. So once it loads, I should be able to see my subscriptions and select that storage account where the SQLDB audit logs are stored. Select the server, select the database. We'll just grab stuff from today and we'll take a look. Okay, so a lot to sort through here. There's definitely better ways of doing this, but what I'm going to do is I'm just going to show you an example. So I found one of these queries from Bob. You can see the query here. Oh, no, it's really small. Execute as user Bob. So this is when he doesn't have access, and it's masked. Now, what I want to call out here is that because we use data classification to classify first and last name as sensitive data, we're actually going to see that here in the bottom under data sensitivity information. We're going to be able to see basically everything that we put in. So it's a medium sensitivity level. We labeled it as confidential GDPR, and it's also labeled as a name, which you would see somewhere in here. I think I'm missing it. But yeah, so this is a great way to not only audit your data, not only classify your data, not only mask your sensitive data, but kind of have it all together so you can get this full picture of who's accessing sensitive data and who can see sensitive data if they are accessing it. So that's a fun example. Related to security, I want to show you another thing. So this is kind of a fun thing. Bob and some security folks taught me how to do this. What we're going to do is we're going to see how well Azure Defender does. Now, Azure Defender is a capability for SQL that includes something called advanced threat protection. And what advanced threat protection does is it tries to monitor against any potential attacks that happen and notify you very quickly. So what I'm going to do is I'm just going to invoke this by doing a new database engine query. I'm not going to go through all the details of this one because I don't think it's worth the time. And like I said, I have all of the, I can't type and talk. Adventure works. I have all of the code in order to do this on your own in the Microsoft Learning Path. So I'm going to connect like that. I'm going to run this query, and hopefully that should trigger a SQL injection attack. So what I'm going to do is, let me just close that. Okay, sorry. Let me close this one. And let's go back to the portal and let's see where we might see this. So I'm going to refresh this page. And on the left-hand side, again, I'm in the same place under security. I'm going to go click Security Center. Now, what we're going to see is that we do have this potential SQL injection. Now, it's registering a count of 2 because I tried 1 this morning to make sure it worked. But we can click into this. So this is part of Azure Defender for SQL. And we can see 10:06. So this is on, not my time zone, but I believe this is on GMT time zone. There was indeed an attempt at this. And you can even click into it and see the status. So you can see that it's active. I can also choose to dismiss it. I can see what query was considered the vulnerable statement, why we think it was the cause, investigation tips to learn more. I can take action and learn more about this. I can even trigger a logic app in the future to kind of respond to these sort of situations. So there's a lot of control I have here. And I don't know if you guys noticed how fast those notifications came up. It's really almost immediate, and you can set up even like text alerts or email alerts for this as well. So that's potential SQL injection, part of advanced threat protection, which is part of Azure Defender for SQL. Now, there's one other piece of Azure Defender for SQL, and that's vulnerability assessment. So what this does, I'm going to click into this. What this does is it's basically going to scan your database once a week if you have this configured. It's going to scan once a week for a number of tests based on various benchmarks that we have available. So you can see this most recent test was ran not too long ago, but if I look at the past, excuse me, if I look at the past tests, I can see the different tests that are there, and I can go into more details about them. But what's more interesting to me right now is the test that failed. So we can check minimal set of principals should be members of fixed high impact database roles. So I can say, oh, what does that mean? And sure enough, I can get a description. And basically what this one is saying, hey, you should set an initial baseline. And once you set a baseline, what we're going to do is every time we scan, we're going to check to see if anything has changed. And if something's changed, we're going to let you know. So this is just another way that we're making your database more secure. And you can see the benchmark reference here. This one is for FedRAMP. You can see the rule that triggered it. You can see remediation. You can see the results. So lots of other things. I can improve this as a baseline. So really awesome, really highly advanced stuff here happening in the Security Center for Azure SQL. And there are a lot more advances that are coming here in this space across all of Azure, leveraging through the Security Center. Let's see. Let me see if I have some questions. What if you have blocks of T-SQL in a procedure that gets uncommented for debugging? Paul, thanks for your question. I'm not exactly sure what you're talking about. I'm guessing you're talking related to the advanced threat protection, but if you add some follow-up there, I'll be sure to check back later. Okay, take a look at time, take a look at our list. Okay, cool. We're doing okay. Next, so we've seen deploy and configure, we've seen security. Now we're going to take a look at some performance topics. So what I'm going to do is I'm going to switch to SSMS, and I have some new queries or views that I think you're going to enjoy. So what I'm going to do first is I'm going to use ostress to kick off a workload. So I'm basically going to kick off this workload. It's running, and now I can explain to you what's happening. Okay, so on this top view, what you're seeing is a join, result of DM exec requests and DM exec sessions, which are things you've probably seen before and are familiar with. And then on the bottom is a new one to Azure SQL Database, which is DMDB resource stats. And that's going to show you things like the average CPU percent. Now this workload is running, and what I want you to notice is that there are a lot of waits happening with SOS scheduler yield, and a lot of things that are runnable that aren't necessarily running. So it means, maybe our performance could be better. If I run this again, we can even see that our CPU is kind of maxing out. So this database is a 2 vCore database. So potentially we might want to do some investigating if increasing CPU could help us in this situation. Now we can still see that, again, a lot of things are runnable. And there's one more query here that I had commented out. And this one is really useful if you have a serverless database. This where status visible online is going to help you track which of your serverless cores are actively being used. So if you deploy between 2 to 8 cores, it'll tell you potentially during this heavy workload that, maybe it's using all of those as opposed to just one when it's more slower or less workload. So let's see if that workload has completed. It usually takes about a minute or two. Looks like it's still running. Now, once this workload completes, we have a few options to go and investigate it. One of those options is the query store. Now, this is something you have on-prem, and this is turned on by default in Azure SQL Database. So, for example, you can go look at the top resource-consuming queries. You can go look at the query weight statistics and see that most of them are coming related to CPU. And then you can even see things related to the various queries. Now, we're not going to dive too deep into that today, but I just wanted to really stress how important that is. In this situation, we've decided that this is a CPU-related issue. So for this workload, we want to scale up. Now, scaling up is easy. I'm going to kick it off, and then I'm going to explain to you what these are. Now, this first result is going to show you some of the limits that you have. So it's going to show you the slow or the service level objective. And you can also see some information to that with this service objective database property as well. So you can see it's a general purpose, Gen 5, that's the hardware, and it's 2 vCore. So I can see the CPU limit is 2. I can see other limits related to memory, max size, max log rate, max IO. All that information is here. And then the final thing that I ran was this alter database. Now, if you want to scale up, you can use the portal, you can use PowerShell, or you can use T-SQL. So here we're using T-SQL to basically scale up to a 8 vCore database. And now if I want to check the operation of if I want to check the status of that operation, I can run this, select all from sysdm operation status. And I can see all the things that are completed or running, and it looks like this one right now has completed this one. It just completed moments ago. So what we're going to do now is we're going to go back to our, let me just close these for a second. We're going to go back to our monitoring resources. We're going to kick off this workload again. Note that last time it took 1 minute and 43 seconds. And we're going to kick that off. So now it's kicking off. We can run this again. And what we see immediately is that we're seeing a lot more running tasks as opposed to runnable. Now, there's still a few, so maybe you could make the argument that we could scale up even more. But what we're really seeing is that a lot of these tasks are able to run. So we can see there's less waits, even some of it has completed. We even see our average CPU down here is lower than it was before. It didn't immediately skyrocket to 99%. Now, again, we can see by these runnables that it's possible, let's see again, that we will hit pretty close to our limits. But it also looks like this workload has already completed. So let's go check. Sure enough, it took about half as long, maybe less than that, to run since we scaled up. So this is just one option you have for performance. And remember, with serverless, you can set up a min and a max, and auto scale to what you need. So you don't have as much delay as you have here. Now, one other performance thing I wanted to show you before we move into availability is the performance dashboard. So this is the performance dashboard. So this is kind of our next section, and it tells you a lot of things here. So you can dive into your query performance insight and kind of filter on different things. And you can also take a look at something like recommendations. So this is something specific to Azure SQL database. So it's giving you recommendations based on its analysis of your workload on what indexes maybe you should create or drop or parameterize. Now, if I click into one of these, I can see how much disk space it's going to need. I can see the index type. I can even view a script if I want to implement this myself, or I can just say to apply it. Now, you also notice this automatically create index in the future. So what does that mean? So if you go to automatic tuning, now this is one of the great things you only get in Azure SQL database. You can actually turn this on. So when it thinks there's a good opportunity, it will wait for a time of low resource usage. It will apply the create index, and then it will monitor to make sure it actually improved your performance. And if it didn't, it will drop the index or kind of roll back whatever it did. But if it did, that's great. So this is a great way to kind of help, especially if you're managing a lot of databases. This can help you in just keeping some of them, automatically tuned. So that's performance. Now, the last one I have, and I think we still have some time, is related to availability. So let's take a look. And I know I said no slides, and I don't have slides, but I have one sample from the high availability by service tier that I wanted to show you. Now, just to remind you that for general purpose, when we look at the underlying architecture, this is similar to a failover cluster instance. So what that means here in this case is that on your primary replica, you have your TempDB running on directly attached SSD. However, your data and log files are stored separately in Azure Premium Storage. So what this means is when a failover needs to occur, what we do is we look for a node with spare capacity, we fail you over, and then we reattach this primary replica to your data and log files. Then we redirect the pointers and get you back up and running. You still don't have to change connection strings or anything like that, but this process could take a few seconds, right? Now, business critical, on the other hand, if you recall from the beginning, we said when you deploy this, you just get an always-on availability group behind the scenes. So you get 3 secondary replicas, one which you can read from. Now, on each replica, you have, of course, TempDB, but you also have the data and log files. So one of the things that this means is when a failover has to occur, or if you force a failover, we simply just change the pointers to one of the secondaries we already have running. So we can fail you over really fast. So that's one of the great things about business critical and general purpose is you can fail over really fast without a ton of downtime, and you don't really have to change anything as long as you have retry logic and resiliency built into your applications. Now, hyperscale is the last one, and its failover time is kind of a mix of the two that we talked about earlier, depending on how many readable replicas you have. So if you have more than one replica, we're going to be able to fail you over quicker, whereas if you have no replicas, it's going to take a little bit longer, a little bit more like general purpose. So I thought a great example, and maybe this is something you've seen from me before, but this is just one I really like. We're going to do this faster failovers exercise. So we're going to compare the failover time for a business critical database versus a general purpose database. So as we look here, we have on the right, we have a business critical database, and on the left, we have a general purpose database. Now, down at the bottom, I want you to notice I'm going to use OStress, and I'm going to run the same query. They're basically the same AdventureWorks. It's basically the same AdventureWorks database. It's just, two separate databases. One is a general purpose, one is a business critical. And so we're basically just querying for availability. So for example, on the business critical database, as long as you see 847, it means this database is available, right? We're just retrying, just hitting it repeatedly. Same thing on the left, except we're hitting a general purpose database. So you also see 847, but for a general purpose database. Now, what I'm going to do is I'm going to force a failover, which you can do with PowerShell. I'm going to force a failover on both of these at approximately the same time. And I want us to observe how long these failovers take. Oops. Okay, so I'm going to kick it off, and hopefully we'll see how it goes. Okay, so immediately I kicked them both off. Immediately you saw the business critical database become unavailable and the general purpose database followed. Now, before I could even finish saying that, this business critical database has already gone back to being available. So you can see just how fast this always on availability group behind the scenes and architecture that you all understand is helping us make these failovers higher and keep this database available more often. Now with general purpose, it takes a few seconds longer. In my experience, it still takes less than 30 seconds, but it takes a few seconds longer because we are, like a failover cluster instance, looking for a node with spare capacity, failing you over, and then changing all the kind of pointers there. So that's a really fun one. I'm glad that it went on well. I see there's a question that says automatic tuning for standard edition. So in Azure SQL Database, we don't have this idea of editions in the way that you might be familiar with SQL Server. Now, some things are available in SQL Server 2019. However, this create and drop index capabilities are only available in Azure SQL Database today. So that's just one of the benefits because you've given Azure control of the server and the infrastructure. We have access to more telemetry, so we can do machine learning behind the scenes to actually, figure out what indexes should be created and dropped. So hopefully that helps answer that question. How can the index recs be pushed back into source control? That's a great question. I'm not exactly sure how you might automate that process. I'm not sure how you would. I think you can access those recommendations outside of that portal view that we saw, but you might have to build something a little custom to kind of, when we get a recommendation, maybe trigger doing that and get it back into our source control. Okay, so great questions. Now the final demo that I have, and I know we're just about at time, is about failover groups. And I'm going to keep this really brief. In the exercises, you'll get to go much deeper, but basically what I've done is I've set up an auto failover group, and the primary is in East US and the secondary is in West US. Now your options are geo-replication or auto failover groups. Today we're looking at auto failover groups, but geo-replication is also a thing. Now the great thing about auto failover groups, and let me just kick off this app. Let's see. So let's just restart this and then hopefully it has started when we come back. Now what we have is the difference between failover groups and geo-replication is with auto failover groups, we give you two endpoints, a read-write endpoint and a read-only endpoint. So what this means is that when a failover occurs, you don't have to update your connection strings. We're going to take care of that for you. So you can failover faster with less downtime and without having to kind of modify any connection string. So that's a really great benefit. You just connect to the read-write or the read-only, and we take care of which one we point you to. So I want you to notice right now East US is in the primary role. And let's take a look at my application. So what this application is doing is it's connecting to the read-write endpoint and trying to insert a row. And then it's connecting to the read-only endpoint and trying to read that row. So we can see right now it's successful for both. So now what I'm going to do is I'm going to initiate a failover. And so you can see what's going to happen is this DR server is going to move into the primary. And you kind of get this nice little graphic of the data moving. But like I mentioned, I don't have to change these endpoints. So I don't have to update any of this or anything like that. It's just going to work in my application. Now in my application, we can take a look, and what we will see one of two things. Either we'll have a delay in the failing over of we'll have a delay in when we see these results, or we'll see some failures. Now it looks like this failover looks like it's still happening, so we should see some failures, but it looks like instead it's just going to freeze. So that's what we have, and now you can see here that the DR server is in the primary role. Now, my guess is that the failover of disconnectedness happened so quickly that this application was able to basically just pause and retry, and we didn't even see any failovers. We can fail back, and you might see some failovers. Sometimes what it says insert was failed, and then it goes back to being able to connect. So you see the insert is failing as this failover is occurring because it's taking a few seconds longer, and then it will, in theory, go back to being able to connect once the failover has completed. So that's also a really interesting exercise, one you'll also have access to on the Microsoft Learn page. We'll see, it looks like it's still failing over, and now it's completed, so we should be able to see some successes soon. But while that's going through, let's talk about what we've learned today, or what you've seen today, which has been a lot. So you saw Azure SQL Database. We talked about deploying it. We talked about security, performance, and availability through lots of different demos. And I guess this one's just not going to work for me today, but that's okay. Remember, I want you to remember these resources here, just these 2 resources. This is all you need. So Azure SQL Fundamentals is going to get you to that Microsoft Learn learning path where you can try every single one of the demos that you just saw today, and you can also learn and kind of spend some more time soaking them in. And then Azure SQL YouTube. This is our YouTube channel. I'm just going to do a tiny plug because, you know, that's what we do these days. But this is our Azure SQL YouTube channel. If you want to stay up to date, we go live every Wednesday. We also release lots of episodes, but if you want more on this topic, we have Azure SQL for Beginners, which is 61-bit videos from Bob and I that goes through the content you just got a glimpse of. And the Azure SQL Bootcamp, which is 4 longer videos going through the same content. So depending on how you like to learn, these resources are available to you. Simon, how'd I do? How are we on time?
You're exactly on time, Anna. There were so many of slides. I was just looking in which slide number you are.
Yeah, there's a lot of demos there. So
As I said, definitely a lot to learn. I mean, it goes over my head, but definitely it makes sense to the people who are watching, and that's great. So, but I have something to show to you. I mean, how do I share my screen? Something I place February 11 and 13. What is that?
Oh, you ordered the book. That's wonderful. That's awesome, Simon. So they're finally delivering.
Yeah, it took a while. I think it started only after, I think, a week back. So, but you know, if I just go and check it, I don't find your name as an author. It's only David there. So there's something.
Oh, I see. Yeah, that's a great book. I'll just give a tiny plug. Like, if you're a developer and you want to learn more about developing with Azure SQL Database, that's a great book. I just played a small part in the authoring of that book, but many really awesome folks from our team also wrote as well, including Davide, who's coming up next, I think. So it's awesome. And, you know, thanks so much for having me, Simon. I hope this was useful for attendees, and I'll be sure to stick around and answer some questions.
Yeah, and thank you so much, Anna. You have been really helpful, right? So that really means a lot. And thank you for all that you do for the community and for supporting a cause. That's really, I'm really thankful for that. And now I'll let you go and have another speaker come in, your friend, David A., who's the co-author of this book. All right, Anna, thank you so much.
Take care. Bye.
Take care. Bye. All right, so that was Anna's session on Learn's Azure SQL Database through demos, so many demos. And now let's go ahead and move to the second final session of the day. That's by David A. I know how it's said now. It's David A. Deliver best practices for Azure SQL, avoiding common pitfalls when using the cloud database. Oh my goodness, that's a long title for a session. All right, let's go ahead and have our next speaker, David A.
Wow, amazing. Thank you.
You love that video?
Oh, I love it, man. That's super
Oh my
cool.
god. Everyone loves that video. We're gonna do it more. Like we have to do these videos a lot
Oh yeah,
more.
definitely. It was nice, going back in time. You pick it up
Mhm.
some very old photos. That was pretty nice.
Yeah, I mean, we went through all social media. It took us a while, but we finally did it. But you have a pretty
That was
interesting
super good.
background. Yeah, you see, I see
Oh.
your background is filled with drawings.
Yeah. My kids, my girl especially, she's super artistic, and so I
Mhm.
started with one, and then also I have a girl and boy. So yeah, of course, this is from the boy. Yeah.
That's pretty
So
interesting.
yeah,
Yeah.
it cheers me up. It's nice to have a kind of a funny office here at home. So
Yeah.
yep.
That's great, Sudhir. I'm really excited for your session, right? Avoiding common pitfalls. This is something that will be very beneficial for the developers.
Yeah.
So I have your screen. I'm going to add it to the stream. And next 45 minutes is
Yeah.
all yours.
Yeah, as you said before, very long title, so lot of content to discuss. So let me just go straight to the point. I can skip my presentation. You already did a great job. Anna already presented the book, so I don't have to say much more on this. It's really a book that we wrote for developers with a developer mindset in mind. So if you are new to Azure SQL, or if you are new to development at all, I think this book will be really perfect for you. This is the book I wish I would have had when I started, developing for work. So I really hope that this will help you and help anyone that who wants to start the development career. Now let's go to the real meat of this session. And as you can see, there are several important points here, and all of these points are related to how to make sure that your application that you are developing or moving from an existing application that maybe you are moving in from on-premises will actually have the best performance in Azure SQL. Because the environment is very similar to on-premises, but there are some infrastructural differences that will emerge, and then we need to take into account in our code. So let's start with the easiest one, resilient connection. You really have to start to keep in mind that this connection will happen. It's not a matter of if or may happen. No, some disconnection will happen. Now, we try to do our best to guarantee 99.99% or even more of availability, but that doesn't mean that you may be disconnected for any other reason. It could be the internet provider, it could be a glitch, it could be in the connection, it could be yourself alone that decide to change the SLO and to upgrade or downgrade your database. So this connection is something that we need to make sure that our application is able to handle nicely without surfacing any error to the end user. There are several ways we can do that. Do it yourself is probably the most complete and probably also the most complex, but is the one that I will show you because it's really a good exercise to understand what happens behind the scene and what kind of error we need to take care of. Once we know how to do that, then we can use some existing framework that basically allows us to make it easier to implement a retry logic, Polly for .NET, Tenacity for Python, but there are basically for any language. If you want to have more details into that, besides the demo I will be showing in a few seconds, there are a couple of articles that we wrote, both on .NET or in general on Azure SQL, or for example, for some specific language in which managing connection could be a little bit trickier than the other, like for example in Java. So you should be covered no matter what language you will be using. Having said that, let me just stress out the highlighted part. Microsoft.data.sql client should be the client you are using to create your application. System.data.sql client is in a kind of maintenance mode because all the new feature are actually development and will be developed on the Microsoft.data.sql client, which is really a drop-in replacement for system.data.sql client. So if you are migrating, you can literally remove system.data, replace it with Microsoft.data, and then the SQL client will behave like the same, but will offer all the new feature and support for all the cool features that will come in future. So let's move to see the demo in action. Nope. So before going to the demo, actually, let me show that all the demos I will be showing you today are available already online. So you can just go to this URL. It's also in the slides, and you will find all the demos I will be showing. So that's a great way for you to just experiment what I will be presenting after the session. Having said that, I already have, of course, cloned the repository in my machine, of course, and then I can just go to the samples, and let's go to the resilient connection. And inside here, you have several options already: .NET, Python, and just generic SQL. So let's go to the .NET. And inside here, we have two examples. One called simple, and let's start with that. One a little bit more complex. Now, the simple one, and just to show you that without doing anything, if you use the latest version of Microsoft.data.SQL client, you already have the ability to automatically recover without literally changing any line of code in your application or writing any additional code in your application from this connection. So this is the demo. I will be connecting it to my database, and then I will just run. We'll just run a very simple select command, right? After that, I will create another thread and kill my session. So I will have a connection. I will spawn another connection. The second connection will kill the first one. And after that happens, the first connection will try to execute something again. But of course, the connection will be severed, right? So there is no connection to use. So what you would normally expect is an exception. We will see that with the latest version of Microsoft.data.SQL client, we don't have to do anything to keep the connection open, or actually, even better, to reopen the connection. And then we will try to run exactly the same code again, but with the automatic or what we call idle connection resiliency turned off, which we can do just by setting connector retry count to 0. And let's see what happens. And in that case, we'll get an error, of course. So let me run. Oh, what's happened? Okay. We replace this. Okay, .NET run. So it will start right now to connect, and of course I have my connection here. So for example, I can just go here. For example, I should have already. Okay, here. Nope, that's not one. Okay, probably I closed it. No big issue. I'm in the lab database. So let me switch to lab, and I can do something like. So just to see which session are actually active in my Azure SQL, and you will probably see Hyperion is my machine. So you see that there is a connection open here, right? Now, so everything is exactly how I would expect to be. So I can now kill my connection, and after the connection has been killed, I will try to execute the application, try to execute the program again, the query again, and the query answers perfectly. So no one recognized or were able to notice. So if I were the end user, that some disconnection was going on. Now, what if I disable this connection resiliency by setting the connection retry count on in the connection string? You see I have my connection. It's a 105. So if I go here, I see that I have my connection. Perfect. And now if I kill this, as you can see, the second time, an error is surfaced because I'm not really managing anything here. I'm not doing a try-catch block. I'm not managing the exception in other way. So here I'm just simply doing, the worst of the worst, I would say. So no exception management at all. But even in that case, idle connection resiliency basically saves the day, because even the worst case, the end user doesn't notice anything. Now, this is the easiest one. And of course, only we basically can do that only when we notice that there is a connection open and the connection is not running any query, right? So in that case, we recognize that that is an idle connection. And so we can actually automatically reestablish the connection and run the query when you need to run it. But of course, there are more complex examples, right, in real world. So we want to move to the advanced sample here, where I created a much more complex example, much more realistic, where we have, and here I have explained everything here in the README, where we have actually, let me go to the README and here. So the application will simulate 3 different conditions using three different threads. The first thread just simulate what happens if you apply the best practice, where you open the connection, execute the query, and close the connection. And you open the connection and close the connection only when you need it and as soon as you have used the connection. So basically, open connection, execute query, close connection. No dead time between all these steps. The second thread actually simulates the case in where you open a connection, then for any reason you don't actually use it, so the connection is left open, you do something else on the application, or maybe the application is just slow, so let's say 2 seconds passes, and then after that 2 seconds has passed, you actually execute a query. So there is a delay between when the connection is open and when the query is executed. The third case and the third thread is when you open a connection. As soon as the connection is being opened, you execute a query, but the query for some reason is really long, like it takes 2 seconds to be executed. Now the question is, what happens if there is a disconnection in any of these 3 cases? How we can recover safely? What will happen in 3 different cases, so that we can learn, first of all, if it's really so important to open a connection only when you need it and close it as soon as you have finished using it. And we will see that this is really important with our own eyes. And if for any reason we can't do that, what we can do to save the day anyway. So let's start the example. Let me just go here and first of all, let me go and comment the code. So this in the code, there is a list of errors that we know are transient. So we need to make sure that if any of error of these happens, we actually retry, because these are network error, database not available error, anything that can be related or to network not being available, or DNS not resolving the name, or disconnection due to the fact that Azure SQL is going through a recycle, for example, when you upgrade your database to a higher service level objective. Then here I defined how many times I want to attempt to automatically reconnect, and how many seconds must pass between each attempt. Now, with the other framework like Poly, you have much more finer tuning on all these options. You can even choose which algorithm to use to add the delay to make sure that you avoid to just trying to reconnect when the connection is not available. But I kept the code very simple, so it will be easier to understand. And then we have 3 options, as you can see here. So the first test will be when, again, I execute my query, opening and closing a connection only when I need it, and as soon as I finished executing my query. And then between the first and the second query, there are 2 seconds delay. Then the second test, the second thread, is where I keep the connection open for 2 seconds before using it. And the third test is where my query will actually take at least 2 seconds to be executed. So let's see what happens when we run this code. So let me clear that, make some space, and let's go. Oh. Okay. The application will start. It will connect to the database called a resiliency test. And as you can see, there are 3 threads. Each one simply, executing a very simple select and reporting which kind of service level objective we are. You see, everything is working. Every second they connect, and every 2 seconds they connect and do something. Now let's go to the database and try to change the service level objective so that basically I'm just simulating the fact that, well, actually, I'm simulating what could happen in real life, right? Because you have an application running, you notice that you need more power, so you want to upgrade your service level objective. So we move from S0 from S1 in this case. So let me execute this, and let's go here and see what's happened. So you will see nothing is happening. Okay, just finish saying that now we have a couple of threads that were trying to execute something while the database changed the service level objective. Now we wait for 5 seconds. After 5 seconds, everything starts to work again. Now, the interesting part here is that the first thread didn't get any error. Only the thread 2 and 3 get errors, right? Why? That's happened because the first thread open the connection, execute the query, and close the connection in the fastest way possible. So it's very unlikely if the query is very fast that you get an error exactly while you are executing such fast query. The other thread, for any reason, were keeping the connection open much more than the thread number 1. So you saw that there was some work for us to do. So, for example, trapping the exception and making sure that we fixed everything. But as you saw, if I, of course, would have created a real application, I wouldn't have surfaced this error to the end user. And yes, the end user, the only thing they would have experienced would have been just a little bit higher latency in normal activity, and that's it. No crashes, no big errors or unpleasant messages. So that's very important. And of course, I can now go back to my first and S0 original service level objective, and again, everything will work nicely again. So very simple example. Code is really pretty easy at the end of the day. And again, you can even use Poly to make it even easier, or Tenacity if you want to use Python. And that's it. So just make sure that right from the start from your application, you write code so that it's resilient to this connection. Okay, now I can stop this, and here we go. So let's move to the other the next slide. And so let me go here and present again. Okay, so connection resiliency is one. Now the second one, and it is super important, on par with the connection resiliency, to make sure that users have a very good experience also when using a cloud application, is try to create applications that are not chatty. So what means for an application to be chatty? Well, before defining that, let's remember that when you are creating something on premises, I think that every one of us followed into the idea that we basically don't have network latency. On premises, usually network is so fast that you don't really take that network latency into account, because it's usually well below the millisecond range of latency. And for latency, it means from when your application start to send a message and when actually Azure SQL receive it, right? So there is a latency here. On premises, usually below milliseconds, so it's almost like not having it. In Azure, things are quite different. Typically in Azure and in general in the cloud. So if you have an application running on a VM, let's say, or an Azure function or a web app, there is a little bit more delay of when your application actually sends a query and when Azure SQL gets it. Now, we are trying to do our best to make sure that that latency will be below the millisecond too. But right now, depending on the region, depending on maybe your application is in a different region than your database, latency can be up to 1 or 2 milliseconds, right? So in that case, every time you send a command to Azure SQL, that 1 millisecond adds up to all the other commands sent to Azure SQL. So if instead asking for, select from a table where the where clause return 1,000 row, you basically execute one command that returns 1,000 row. So you just wait for 1 millisecond for the command to reach SQL. And then let's say it takes 100 milliseconds to fetch the row and send everything back. But still, 1 millisecond is basically nothing compared to the real time needed to execute the command. But what if instead of executing one command that returns 1,000 rows, you execute 1,000 commands, each one returning one row? The single 1 millisecond must be multiplied by all the commands, right? So basically, you will just wait for 1 second just to wait the command to go back and forth. So this will, of course, increase a lot your latency. If you are moving an existing application, maybe a legacy application on the cloud, it could happen that your application is doing a lot of requests to SQL Server, and when you are on the cloud on Azure SQL. So, for example, we had found that there are some applications that actually do from 500 to 3,000 or even more queries for each business transaction, where business transaction means, for example, fetching an order, information, fetching a client data, showing something on a UI. So, of course, if you have, let's say, 1,000 queries that you need to run to open up your form, your web page, and you are on premises, the bar that we'll see on the left, that you see on the left that is blue, will move to the green one very fast. Like, it's fast enough that no one will complain. But if you move everything on the cloud, you will see now that the bar from blue will become green in a way slower fashion, right? And if in your application you need to execute this kind of business transaction more than once per UI, chances are that the user can, wait just 3, 4, 5, 10 seconds just due to latency and chattiness. So the message here is make sure that you use as much as possible a set-based approach instead of sending, 1,000 times one row. Send one set of 1,000 row, but one time. That's completely different. That will basically completely solve the network latency problem. So how can you do that? Like, for example, let's say you have a storage procedure and you need to insert 1,000 rows, and you know very well that storage procedure, or maybe you remember from the past, the storage procedure cannot accept arrays or tables, right? So how can you actually send a set of 1,000 rows as an input to a single storage procedure? Well, there are ways to do that. One is with table value parameters, which actually allows you to send a table as a parameter for a storage procedure. But not all languages support that. So in order to support that special parameter style, the client, for example, the .NET client in this case, needs to be aware of this special parameter. And .NET, of course, supports it. But for example, Python doesn't. So with Python, you could use JSON, because JSON, it's perfect. You can just serialize your array into a JSON and then send it over the wire. Storage procedure can easily open JSON, and since JSON is actually an array, you just have actually passed an array to a storage procedure, and that's it. Or you have the bulk insert. Now, to show how these can impact the performance, I prepared an example where I show not only these 3 cases, but many more. So you can have a real glimpse of what means to use the correct tool to transfer data to Azure SQL. So let's go to this sample here, network latency. I won't go through the code because we don't have enough time, but again, all the code is available and it's pretty easy. Basically, I'm loading 1,000 rows, right? I'm looking for the fastest way from my on-premises machine right now, so where latency is even higher, to load 1,000 rows as fast as possible in Azure SQL. So let me go back to the correct folder and 07 and just run the sample. So I have to go .NET. Okay, so let's run the sample, and basically you will see that all we are doing is try to insert 1,000 insert. The first time we are doing literally calling 1,000 times the storage procedure that will do one insert. The second, and as you can see, it's pretty slow, right? Because from my machine, where latency is very high compared to what I have on Azure, it will take something like 20 or more seconds. and maybe more because I have kids now playing Rocket League. So maybe it will take more than that. Anyway, plus we also, 34 seconds. So usually it was 20 something. There are other solutions that allows you to actually send a list of objects to a as a parameter to a storage procedure, for example, using Dapper. But actually behind the scene, they are really calling the storage procedure again 1,000 times for you. It's simply a little bit of code sugar to simplify your code, but behavior is the same. So it will still take 30 something seconds. So the trick is, for real, sending one array of 1,000 rows to the storage procedure. And that is something we can do with a table value parameter. And as you can see, the difference in time is absolutely amazing. JSON usually is on par with TVP, but again, I think today between me streaming, kids playing, my local latency is very low. It's very high. And there are other options like using raw constructors. But using bulk copy, that is really, really, really fast. So we went from 34 seconds to 0.8 seconds to pass exactly the same data, right? So just to give you an idea how higher the performance of your application could be if you choose the right way to send data to Azure SQL. So this is very good to keep in mind because it can completely change the way your user will see the application from a performance perspective. Now, let me go back here and see. Okay, no questions so far, so perfect. So let me move now to other slide where I also run some tests, of course, on Azure, moving data from Azure VM in the same region to Azure SQL in the same region. And as you can see, of course, performance are way better than what I could do from on-premise to Azure. So I can move 3,000 rows in only 4.5 seconds, even using a very basic loop. So not too bad, but still it's 5 seconds. But if I move to bulk insert or TVP or JSON, all these choice outperforms the brute force approach of 3,000 command, 3,000 insert. This is one command with 3,000 rows. And as you can see, the improvement is amazing. So this really makes difference, create a huge performance improvement for your application. Now, another thing that will really help your application to scale and again to get a much better performance from a user perspective is using the read committed snapshot. Now, luckily, this is done by default. So this is very important for you to know because it's a different behavior by default than what we have on premises. On premises, we have to keep a default that is compatible with everything that we have done in the previous year. In Azure SQL, we decided to go with what we call the read committed snapshot that will immediately unlock better performance for your application. Let me show you how in a very easy example. So let me take a couple of queries that I have here. So let's take this first query, or maybe I already have, nope. So let me connect to the wide word importer standard database, our well-known sample database, and let me connect twice, one because I need two connections. So I'm simulating a case of concurrency where I have two different applications, one that is trying to update some data, and the other that is trying to read some data. And let's say that for some reason, the application that is trying to change the data is somehow slower due to latency, due to the fact that I open a connection and then I started doing something else before executing a command. So in both cases, let's see what happened. So this is the data I already have in my table. So I have some cities available in my database. I have Bellevue, I have Kirkland, I have Redmond, all cities around here in Seattle. And let's say that one connection, one application start a transaction and then start to say, okay, I want to insert some new data. I need to completely delete Bellevue for some reason. I need to update, this specific row for Kirkland. And of course, all this data, all these changes will be available to that application that make those changes, because the application is, started the transaction, all the command being executed are in the same transaction. So here I'm seeing the changes. On premises, what would normally happen if another application start to use the database, for example, trying to get a list of all the location in the city called Kirkland, Redmond, and Bellevue. Well, that's exactly what will happen. The application will hang, because by default, and this is not something you will normally specify on premises, but this is the default behavior on premises. Read committed lock, which means that the application will stop and wait for the data to be committed or roll back, because only the data that has been committed, that's why it's called the read committed isolation level, the isolation level we are using, because only the committed data are allowed to be sent to anyone asking for it. The problem is that here we are waiting. In theory, since this data is not yet committed, what we could also do is just read the old data, the data that it was committed before the other application started the transaction. So this is exactly what happened in Azure SQL. By default, without specifying anything, you will be able to read the pre-existing data, the data that existed before anyone started to try to change anything. So as you can see here, immediately my application will be more responsive because it doesn't have to wait for maybe a long transaction to be finished. So this is pretty cool, because without literally doing anything, by default, if you are moving an application, that will have better performance, or at least better perceived performance. Or if you are just starting in the cloud, you have this beautiful behavior for free without literally doing nothing special. Now, other important things to know when you are working on Azure. Updates and deletes are, of course, something that you will do every day in your application, but they have a little bit, overhead, a little bit of overhead, because in Azure we have something called accelerated data recovery, which means that, let's say you run a transaction, and the transaction takes hours to complete, but at some point, someone that you may not be aware of, but starts, maybe your database administrator, or even an automatic system alone, starts to upgrade the database from S0 to S1, or from P0 to P6. Now, if your transaction is being running for an hour, usually what would have happened is that we have to roll back the transaction, and normally that would have taken exactly the same amount of time. That cannot work in the cloud, of course, because it's not that I can ask a database to move to a higher tier now and wait maybe an hour before that happens. So we had to create a new technology called accelerated database recovery, which as soon as you ask us to interrupt transaction, we can immediately cancel it. So we don't have to wait for the redo to happen. We can just say, okay, transaction canceled, completely undo everything you have done, and using the version that we kept, that you also saw before with the snapshot isolation level, we can immediately give you the version that existed before someone started doing the changes. Of course, this is as an overhead, which means that deleting updates can result in to be a little bit slower than on premises. So one way to solve that is, first of all, to avoid very long transaction. If you cannot avoid, so if you have to delete 1 million rows and there is no way that you can delete that with other technique, later I will show you one. One option to avoid to use a lot of resources, keep locking, maybe even locking the entire table for a long time, is to delete the row in chunks. So basically doing a delete top n and do a loop until the rows are deleted or appear, or use a link called row lock to make sure that Azure SQL always put the lock on each row instead of locking the entire table. Of course, this is a kind of a trade-off between concurrency and memory usage. So this needs to be taught a little bit, but that's important to keep in mind in case you really need to delete, 5 million rows out of 6 million that are in your table. Another thing that you want to keep in mind, which is very common in application, is that many times you want to delete or update something and then return the values that has been deleted or updated to the end user, just to say, okay, this is the data that we have deleted. So normally what people would do is, first of all, run a select that has the same where clause that will be used in the update or delete, and then update or delete effectively the rows. This is an issue, of course, because between the delete and the time when you actually do an update or a delete, between the select and when you actually do an update or a delete, may pass, maybe a millisecond, maybe a second, and in that time things can change. So probably you want to create a transaction to make sure that everything is used is executed as a whole, and so you don't have inconsistency. But a big transaction means locking, and locking means potentially concurrency. So how can you solve the problem without having to pay for this in some way? Well, there is a very good option that you can use, that is the output clause. So for example, you can do delete from and output to, so that the rows will be deleted and automatically the result will be sent to the output, just like if you would have executed a select statement. So let me show that. It's pretty interesting, and I recently answered an email, a question on that on Stack Overflow. So it's a very common request. I can close all this stuff here, and let me open the example. It's very quick and easy. Here we go. Move to database where it has all the data that I need, but I don't think I'm going even to execute the code. I just want to show you, maybe I will execute the delete one. I just want to show you how can you do that. So basically, this is the trick to do the delete of a big number of rows just by deleting them in chunk of 10,000 in this case, to make sure that the transaction is always small and you don't lock too much. But what I really want to show you is this. So let's say I have some data in my order table. So let's say, for example, I want to delete all the orders done by clerk 1. So what I would normally do is something like that. And of course, if I do that without the output clause here, I will just delete the data and I won't be able to get the output. But if I do that instead, I will delete data and I will get the output. In just one transaction, no need to select anything, no need to create explicit transaction. So that's very nice, because you can always return the data that has been affected while you are actually changing database. And this is even better for the update. Let's say that you really want to show what kind of update has been done to the database to your user. You can do an update, and by putting the primary key, and let's say here I'm just changing the comment, right? So I want to return the previous comment, so the comment that I updated, and the current value. So I can do that, and so I can show to my user, okay, I updated this comment for this order to comment here. So this is very nice, very handy. Will make your code way simpler, because you don't have to deal with opening a transaction, executing a select, then executing the update, closing the transaction. Your code, even your C# or the question on Stack Overflow was done using Tedious and Node.js. Instead of being like, 10, 15 rows of code, will be probably 1 or 2. So way to go to simplify not only the database code, but also your application code. And of course, all these examples are available in the GitHub repo I'm using. Now, another very common requirement is how you can load data into Azure SQL. Maybe you have a CSV, maybe you have a JSON data, a JSON file, and you want to import it in Azure SQL, or in some cases, you even just want to query the external JSON file without importing it in Azure SQL. Is that possible? Yeah. So you have two options here. You can quickly import data that is, let's say, sitting, for example, in a blob store using bulk insert or open roset, or you can just read the data that is sitting in a blob store using, for example, select from open roset. These kind of topics are very common. So I created not one but two repositories specifically dedicated on to show how you can quickly import data into Azure SQL. One is exactly the one I will be showing you. If you are also into big data or using Databricks, I also created a dedicated GitHub repository where you can see how to really quickly load data from Databricks into Azure SQL using table partitioning, partition switching, and all the most advanced technique to really make it go as fast as possible. So that will be something that will be very useful if you are also in that area. So the repository is I'm using right now is not the samples, even if I put a link to the correct repository here, and the sample is this one, Azure SQL DB import data. So you have different samples on how you can actually import data using, for example, the BCP on your machine, using bulk insert on Azure SQL, using PowerShell, for example. What I'm going to show you right now is a very simple example on how to just use pure T-SQL to import data. So let me move here. What I'm doing is, let me clean up everything. Perfect. And so I'm just, okay, let me, that's fine. Okay, so what I want to do is, that's probably not the database. Yes, I have to go to import sample. That's the database I usually use for this kind of example. Here we go. So let me clean up everything. Nice. So let me be sure that everything is good. Okay, so what I want to do is import some data that is sitting here in my Azure Blob Store, and specifically into this folder, into this container, right? So what I would normally do is just right-click, get the shared access signature, copy, create, and copy the query string. Okay, now I just have to create, first of all, the what we call the scope of the credential to keep the secret somewhere. Make sure that you remove the question mark at the beginning and execute that so that you can safely store the shared access signature into Azure SQL. And that will return an error because since these are sensitive data, it needs to be encrypted. So we need to create a master key before. So I'm creating a master key. Now all my secrets will be safely encrypted. And that's it. I have stored safely my shared access signature. Now I want to create an external data source that points exactly to my account and container, and saying that I want Azure SQL to be able to access that container using credentials stored here. With that, I can just go into the import demo and, for example, import the customer table I have saved before, or someone exported for me. But also, as you can see, I also have JSON data here. So let's say I want to read the JSON file without importing, for example. I can do that. Select and from a column called bulk column, open row set. And this is just the file I want to read. This is where the file is available, and that's it. Here is my JSON file. This is the content of the JSON read directly from Azure Storage. Of course, this is JSON, so I can probably see it as a key value pair if I want, just using the OpenJSON function, or I can even turn it into a proper table by using OpenJSON with the with clause. And as you can see here, I'm really literally reading a JSON file, but treating it as a table, even if this table doesn't exist at all in Azure SQL. There are some rough cases I found. For example, there are some cases, situation where JSON is exported like a concatenated JSON. So you have one JSON document and then some space and then another JSON document. This is not a valid JSON, right? Because we have just concatenated several valid JSON document. But sometimes I have found, this issue. So how can you do that? Very easy. I can still import my file. And then, for example, in this case, I know that I have to split each row using the line feeder, and that's it. Now I have each JSON separated into its own column. And then if I want, I can then use OpenJSON to turn that JSON into a table or extract the data I need and do everything. The bottom line here is that I'm always reading from the storage and not from the database. And what if instead I want to import data? Let's say I have my customer data, customer table. I want to quickly import some table data that has been exported in a flat file format, so kind of a CSV. I can just do bulk import the file, again, the data source, some information on how to split the fields, and that's it. Now my data will be quickly imported into SQL, and now I can just manipulate my table with the data imported. I can also avoid to import data if I don't want to import my data into a table, but I want to run some query on a CSV file, on a flat file. In that case, I need to have also a format file that will actually allow Azure SQL to understand that this column is a string column and is named C address. So this format file is something you need to provide, and will look like something like that. So if this is the file I am giving as input, how can Azure SQL can read this file? And here it's basically the rules. The first column is a char of 50. It's divided by the next column with a pipe, and I want to call this column key, and so on. So with that, I think we are almost done. I think I have time for another demo. I will just do this one, and I think then we are pretty good. So, sorry.
Just sorry to interrupt. Do you see your screen freezing? Do you feel that?
Oh, you see my screen freezing? Oh, man. Oh. Can you see now? I'm projecting the SSMS, SQL Server Management Studio.
I see Visual Studio Code, Visual Studio.
Visual Studio, so a bunch of data with an open row set.
It says from open bulk import demo user.
Right. Okay,
Perfect.
So maybe it was a temporary issue. Okay, so let's see if we have enough time. So let's see. Let's go here, and let me take the partition sample. Yeah, probably I won't have time to load and run everything, but I can just show something. And then everything it's available on GitHub, so you can really do it yourself. But what I want to show is that let's say you have a table, and you have a big table, like in this case was a 75 million rows table. And for some reason, at some point, you want to delete all the rows of a certain date. If you have partitioned such table so that, for example, you have let me pick the code here. Here we go. You can basically create a table such in a way is partitioned, means that each order that is done in a specific year will actually be saved in a specific partition. One thing you can do is actually do something like that. Truncate table and specify the partition. This means that basically you are completely wiping out that partition. But if that partition contains all the data of a specific day, or of a specific order, or of a specific customer, you are basically just have found a way to quickly, completely delete a bunch of data that may be to completely reload in a very fast way. This will always take some milliseconds, because basically you are completely dropping all the pages related to the partition, which is completely different than deleting. So this is much faster because we're just dropping pages instead of deleting rows. So this is using partitioning even in the cloud. It's very useful because it allows you to do this kind of set-based manipulation very quickly. For example, you can even completely move one partition into another table and do the update and move the table back into the original partition. So these tricks allows you to quickly do delete and update that I told you before could be slow if you need them on a really huge block of data. So partitioning is not only useful on premises where you normally you would have used it to send data to specific file groups, which usually would have resided on a specific disk drive to maximize the IO throughput. Of course, this is not needed in the Azure because you don't manage the file, but still it's needed because, for example, it allows you these quick, tricks that allows you to quickly move data around without actually moving data, but moving pointers, which is much faster, but still produce exactly the same result. Also, the sample is completely available online. So I think we just have a couple of minutes for questions if you have any. Let me just go here. And yeah, I think I show a lot of stuff, but yeah, I just wanted to make sure that you see all the important points so that you can then go and do it yourself on the repository that is available here. So this is for example, this is the repository you want to reach. But I guess there will be a way for giving you the slides, Simon, so that they will be made available and people can download the slide. And every single demo I did is available in the repository, so you can really try it on your own. Let's see if there are any questions. Doesn't seem so. Okay, and okay, I think I'm good. Right on time, as far as I understand, right?
Yeah, perfectly on time, David. I think that was a very detailed session, right? You went through many demos, and there's a lot of things going on. I didn't see many slides, but there's a lot of VS code running, and there's a lot of code. That definitely goes over my head. but a very detailed session, and a lot of best practices. Go ahead and take it. I think this will be very helpful to many people who go ahead and watch it later on. If people are not able to watch it now, we'll just go ahead and divide it in every session. So David, thank you so much for your time. We really appreciate it, to whatever you do for the community and for the cause.
Sure.
Thank you so much.
Thank you so much
love
for
to have you
organizing
back.
it.
All right, David. Have a nice
Bye.
weekend. Bye. Take care. All right. So with that, we move to our final session of the day, and that is by Mara. So Mara is going to talk about data replication options in Azure SQL and SQL Server. So let's go and invite Mara to end the day one of the SQL Server Virtual Conference. Hi, Mara. Welcome to the conference.
Hi, thanks for having me. I was not expecting that introduction.
To be honest, no one was expecting those videos. I think these videos are something speakers really love. We don't tell them that we are making those videos, and we just play them like they really love it. So, Mara, thank you so much for your time. I know you're really rushing for the other meeting, so I'll let you go ahead and get started with your session. And do you want to go ahead and share your screen so that?
Yes. Let's see.
So did Anna feel? Anna says, "Hi, Mara, great intro video."
Thank you.
Guess what? At my place, it's 5 a.m. and it's like 12 hour
Wow.
streaming.
Let me know when you can see my
Okay,
screen.
it's loading. Yes, I see the presentation. Yes, now it's in slideshow mode. So next 20, 25, 27 minutes is all yours.
Great. Sounds good. Should I get started?
Yes, you can.
Okay. Perfect. Thank you. Hi, everyone. Very excited to be here. As you've seen in my very detailed intro, I'm a PM at Microsoft in Azure SQL, and I'm very excited to give you some information about data replication options in Azure SQL PaaS services. So this is what we have prepared for today. We'll start at a very high level. Why is data replication relevant? And then we'll go a bit into more depth in common scenarios and solutions for data replication. So the list that I will go through is in no ways the most comprehensive list of options. There are so many other scenarios, there are so many other great solutions, third-party apps, but these are some of the key replication options that I thought would be interesting to discuss for today. So we'll go to SQL data sync, change data capture, change tracking, active geo-replication, and read scale-out feature. Great, and just to give you some context for the discussion, so I'm sure the other speakers have already told you about the great offerings in Azure SQL, all the way from infrastructure as a service up to platform as a service. The context for this talk will be mostly focused on Azure SQL database replication solutions. However, some of the solutions also apply to SQL Server on-prem, on other VMs, or Azure SQL MI, but we'll be mostly focusing on Azure SQL DB, just to clarify the context for the talk. Okay, so let's get started. So very briefly, why is data replication relevant? There are so many use cases for that data replication in the daily life. So if you, for instance, if you are an emergency 911 system and you want to make sure that any call you receive is automatically visible across the country to mobilize resources as needed for any patients, you would need real-time data replication. If you're a business and you sell and you want to make sure your inventory is in sync across multiple regions, actually we'll see a demo around that, you would use, again, data replication. So there are so many uses for data replication in our daily lives. But now let's go a bit into more depth into data replication. So we'll go through these key scenarios for today. So we are going to discuss some solutions for synchronizing distributed applications. And here we're going to see synchronizing data across databases that store different workloads. So you might have a production database that you want to synchronize with another database that has analytics workload. Then you might use replication for business continuity, which is essential, and this refers to the procedures that that would enable your business to operate even in the face of disruptions such as data center outages, large-scale outages, and regional disasters, and so on. You might also want to use replication for scaling out read-only workloads, so to offload your read-only workloads instead of running them on the read-write replica. So this way, some read-only workloads can be isolated, and they will not affect the performance of read-write replicas. And lastly, you might want to keep data synchronized also while migrating and also after migrating. So you might say, I want my source database on-prem and my target database on Azure SQL to be synchronized during migration and after, so that they remain functional. So these are some scenarios that we are going to look into today, and now we are going to start exploring these solutions into a bit more depth. So we're going to start with SQL Data Sync. I might be biased here because I'm the PM for SQL Data Sync, so we'll also do a demo here. So SQL Data Sync at a very high level allows you to synchronize data among databases that are in Azure SQL and SQL Server on-prem or on other VMs. And the whole synchronization is around the concept of a sync group. A sync group is just a group of databases that you want to synchronize, and it consists of one hub database that has to be on Azure SQL and one or more databases that can also be on other SQL Server instances, for instance on-prem. So some properties around sync groups we'll see in the demo as well, but you would set up the sync schema, which basically specifies what are the tables that you want synchronized within a database. Then you set up sync direction, and what is really interesting about SQL Data Sync is that it allows you to do bidirectional synchronization as well, so not just one way. So more specifically, you can do sync from member to hub, hub to member, and both. Then you can set up the sync frequency, so you can set it up as little as 1 second at as large as 30 days. Here is worth mentioning, even if you set it up 1 second, this doesn't mean that the sync is real time, but it will take 1 second from when the last sync was completed, and the new sync will be triggered within a second. So that's what this means more specifically. And conflict resolving policy. So this defines what should happen when you have conflict in terms of data modification. And here you have two options. You can either say the hub wins, in which case changes in the hub will override those in the members. And then you can select member wins, in which is the opposite. Changes in the member would override those in the hub. So as you can see here, you have a hub and spoke topology for SQL data sync. So all the member databases only sync to the hub database. So if you want to synchronize multiple member databases that are on SQL Server on-prem, for instance, you can do that, but indirectly through the hub database, which is on Azure SQL. So more specifically, changes from the hub are downloaded to the member, and then changes from the member uploaded to the hub. It's also important to know that if you are using member databases that are on-prem, you will have to install a local sync agent. And so SQL data sync works through DML triggers like insert, update, deletes, which are recorded in a site table in the user's database. We'll see in the demo. And since it's trigger-based, transactional consistency is not guaranteed, but eventual consistency is guaranteed. So data sync does not cause data loss. So before going on to the demo, just some use cases specifically for sync. It allows hybrid data synchronization. So this is great if you want to, if you're considering moving to the cloud and would like to put some of your application in Azure. This is a great for you. It's also great for distributed applications. We talked about it already. And lastly, for globally distributed applications. And this is helpful because in order to minimize network latency, it's best to have your data in a region close to you and make sure it's synchronized with other data. Great. So now we're gonna do a demo for SQL Data Sync, in which we'll synchronize two Azure SQL databases across US and Asia. Let's see. I'll play this to make sure there are no glitches. Here you can see the hub database. It's a fruit business. We see a fruit inventory, very simple. We have some fruits and want to make sure our inventory is in sync with our Asia center, where we can see only 3 of the sales have been recorded so far. So the melon has not been recorded, and we want to make sure all data is in sync. And then we'll add some more to the inventories to bidirectional sync. So I go on the hub database and create a sync group. Here I set up the sync group name, let's say US to Asia, because we're syncing data across these regions. You have to set up, you can either choose an existing database for metadata or a new one. We recommend you do a new metadata database. It has to be in the same region as the hub database. And we'll do it as a basic pricing tier because that's enough for the purpose of this demo. And automatic sync, we want the sync to be triggered every 2 seconds. And we want hub win in case we have any conflict for data modification. Private link ensures that connection between your hub database, here you can learn more, hub database and the sync service is secure. So it's a private endpoint, a private IP address that is managed by Microsoft. It's still in public preview. So what you have to do is to do a manual approval for the private endpoint before you can move onwards. So here we're approving the private link. So this is being approved, and now the sync group should be created. And now we want to add member databases. So we have to log in on the hub database on Azure SQL. And then here you can see you can add either from on-prem or from Azure. We're going to add another Azure member, the Asia database. And I'll go to my test server in Asia. And I select, and I do bidirectional sync, which we talked about. And again, I have to log on with the credential for the server in Asia. And I use private link again for the connection between the sync service and the member database to make sure that's all secure. So I will use that private endpoint. Private link only works if your hub and members are in Azure as of now. So if you have on-prem, it won't work. And now I'm going again on the Azure test server to approve the private endpoint. I have to manually approve it once again before I can have the member added to the sync group. Okay, so now I move onwards. Now we created a sync group, added members, and now we select the data that we actually want to synchronize. So we refresh schema on the hub. Only the tables that have a primary key will be shown here. So primary key is necessary if you want to add that specific table. So in this case, I will just synchronize all the data. It's very little data for the purposes of this demo. And I'll do the same for the member database. I'll select which data I want synchronized. And as you can see, we have primary key again, which is essential. Here you can see the status, and you can also get logs on monitoring. And the sync group has been created. I'm showing you again the logs and the databases. And now let's see whether the synchronization actually happened. So the expected behavior is to see same data in Asia that we had in the US, right? Because one of the items in the inventory was missing in Asia. And I'll go again to the Asia database as well to check it out on the query editor. So as you can see, sync adds some tables on the user's database. On the hub and the member databases, you can see those tables that have been added. And they have different sync schema and other detail about the sync operation. Now we're checking to make sure that we have synchronized data in both regions. So in Asia, it seems that we had that item that was missing initially. And I'm showing you here that is the same as in the US. So the synchronization worked, but just to make sure it's bidirectional, so not just from hub to member, but also the other way around, I will insert some value in Asia as well, and we'll check if it shows up in the US. And I'm gonna add a dragon fruit. As you might see, I made a spelling error, so this won't work, and then I'll fix it. Okay, so we added this, and then we're gonna check if it shows up in the US because we set up bidirectional sync. It takes a bit, as I previously mentioned. It takes a little, so I'll go back to it. I went back to the Asia ones, and now I'm running this again. Let's see, and this shows. So the sync has happened bidirectionally on both member and hub. Great. Let's move onwards. Oops. Just a second. So we'll move onwards to change data capture. So, okay. So change data capture allows you to record, again, DML changes in SQL Server, Azure SQL MI, and soon on Azure SQL DB. So keep an eye out on that. So as you can see on this diagram, as DML changes are made to source table, they are added to transactions log, and then you have a capture process reading from the log and adding changes to the track tables, associated change tables, and CDC functions afterwards enumerate changes from the change tables and return them in a result set, in a filter result set, which you can use for other purposes afterwards. In this case, we got the data, change data from OLTP into a data warehouse. So there are some key concepts around CDC. You have the change table. So each insert update operation appears as a single row in the change table. So column values after insert and the column values before the delete. And for update, you would have one row entry to identify values before update, and second row to identify column values after the update. Then you have the capture process. So as already discussed, we already discussed about it, but it's important to highlight that because the capture process extracts change data from the transaction log, there is a built-in latency between the time a change is committed to a source table and the time that you can see it in the change table, but that latency is typically small, and also the maximum number of capture instances that can be associated with a single source table is 2. And through capture instance, I mean a change table and maximum 2 query functions. And last of all objects associated with the capture instance are in the CDC schema of the enabled DB, and we'll see that in a moment. Then you have the cleanup process. So this is very important because it's responsible for enforcing the retention-based cleanup policy. So it basically it removes expired change table entries, and by default, 3 days of data are retained. And lastly, you have the CDC query functions to obtain the change information. So in order to enable CDC, you have to do that first at the database level. So you have to run this stroke procedure that I'm showing you here. And once you do that, you will create the CDC schema, and the system tables will be created. Afterwards, within that database, you also have to enable CDC at the tables level. And once you do that, you'll have the capture and the cleanup jobs created. And you also have a table to track changes on the source table. You can see that up there. So it's very important to ensure that SQL Server agent is enabled for the 2 jobs to be created, the cleanup and the capture. And also, if you want to monitor CDC, SQL Server has dynamic management views for that. Use cases specifically for CDC, very many. You can track data changes for audit purposes. You can send them to other subscribers, do analytics on change data, ETL operations, event-based programming. You can run AI models on them. There's so much you can do with CDC. Great, and now let's see change tracking. So change tracking is also similar but different from CDC because it records that in a table rows were changed, so without capturing the actual data that was changed. So after you configure change tracking on a table, any DML statement that affects rows in the table will cause change tracking information to be recorded. But while change tracking, so you can see that an operation has been done, such as update, delete, insert, and the value of the column for the primary key of that row, as you can see here. Some key concepts: you have the change tracking table. Every table with change tracking enabled, similar to CDC, but in this case, you have an internal on this table used by the change tracking functions to determine change versions and rows changed since a particular version. Then you have the change tracking query function. So these again supply the details on the changes in an easily consumed format. So you can get all kind of data on the changes. Then you have an auto cleanup policy, as we've seen before, and a change tracking current version, which is interesting because so every time a user accesses a table, you can get the version number active at that moment. And if you keep that version number safely stored somewhere, next time when you go and access the table again, you can get the net change data from that version number. So that actually is very valuable. A small comparison between change tracking and CDC. You can see one of them is synchronous and asynchronous. Change tracking mainly tells you, yes, a change has been made, while CDC also shows you historical change data. And because of that, CDC, of course, has more overhead. So when we talk about storage and performance overhead, while change tracking has less. So both of them are similar in the sense that you have to first enable them at the database level and then at the tables level. and both can be enabled on the same database without additional considerations. Again, to enable change tracking, as I was mentioning, you have to do that on the database level. As you can see here, you have the retention policy. You can configure that. And then when you enable it at the table level, column tracking basically enables your application to synchronize only those columns that were updated. So this is great because you can improve efficiency and performance. However, maintaining column tracking also adds some extra storage overhead. So this is off by default. That's why you have to specifically put it as on. And then you can see how to determine whether change tracking has been enabled, and one example of a function that would get you the version number. And now let's move onwards to active geo-replication. So with active geo-replication, you can create readable secondaries of Azure SQL databases on servers in the same or different regions. And this is great for business continuity, especially because it allows the application to perform quick disaster recovery of individual databases if you have outages and disasters like natural disasters, human errors, malicious acts, and so on. So it asynchronously replicates committed transactions on the primary to a secondary. So asynchronously, well, at any given point in time, the secondary might be slightly behind the primary, but the secondary is guaranteed to never have partial transactions. Up to 4 secondaries are supported in same or different regions. And again, the failover has to be manually initiated by the user, and afterwards the new primary has a different connection endpoint. Some specific scenarios in this case, you might use this for database migration. So you can use it to migrate a database from one server to another online with minimum downtime, and for application upgrades. So for instance, you can create an extra secondary as a failback copy during application upgrades. And you can also use it for load balancing read-only workloads, which we discussed about a few minutes earlier. So this is not supported on Azure SQL MI. So if you are looking for Azure SQL MI, you might want to look into auto failover groups. And that's pretty much it for active geo-replication. And lastly, for the read scale out feature, let's see. So basically, this works in premium, business critical, and hyperscale. And these tiers are provisioned with one or more secondary replicas, which can be used for like load balancing read-only workloads. So for basic, standard, and general purpose, these do not include replicas, and the read scale out feature is not available in these service tiers. However, like each single database, elastic pool, and managed instance in the premium and business critical are automatically provisioned with the primary read-write replica and several secondary read-only replicas. And for hyperscale, by default, you have one secondary replica created for a new database. So you can configure the SQL connection string to direct your application to a corresponding replica. Again, to monitor, you can use dynamic management views. And if you have a long-running query causing blocking, it will automatically be terminated. And true blocking will mean if an object modified on the primary while the query logs the same object on the read-only replica. And lastly, it's always transactionally consistent state, but at different points in time, there may be some small latency between different replicas. Great. So to bring this all together, we've been looking at some interesting scenarios like synchronizing different workloads across regions and scaling out read-only workloads. We explored some of these solutions. Time has been very limited, so we didn't have the chance to go in depth for all of them. And this is in no means the most comprehensive list. I encourage you to do more digging into these, and please feel free to reach out with questions or feedback. And yes, this is all. Thank you.
Oh, wow, Maura, that was a very crisp presentation. I never felt that data replication has so much to go ahead and learn, because I don't see many people talking about it. So that was a really nice session to go ahead and see, and really loved it.
Thank you. Thanks for having me.
So I know, Mara, you're running late for your other event. So thank you so much for your time, Mara. Thank you so much for all that you do for the community. We would love to have you back next time when you're available, and we'll make sure that we play that video once again.
Awesome. Thank you so
All
much.
right, bye. Thank you. Bye. Take care. All right. So with that, we are at the end of final day. Look at that with the new background. What did you do?
You like my new background? Huh? You made it. Let's say
Yeah.
non-stop 12 hours.
Yeah, I think yeah, and we are only halfway down. I think tomorrow we have another 12 hours coming up. So yeah, in less than 11 hours actually.
Wow. So you need to get some sleep. It's like almost 6 a.m. there, huh? 5 something.
Yeah, yes, almost like 5:30 a.m. at my place, and me and my team, we are still very active.
All right. So let's close it out. So first of all, I would like to thank everybody who has joined us. We saw a lot of people joined from almost every part of the world, right? From US, Europe, India, and Asia, everywhere. We have thousands of people joined today for this learning purposes of SQL Server. We also have, our speakers. We had 14 different sessions by 15 speakers. They were all great. And we definitely thank you for all, speakers. They have also donated for the cause. And then we have 2 sponsors, Redgate. I'm sure most of you already know Redgate has tools for software development and database, professionals. If you have, you're looking for a tool, check out their website, Redgate. And also SQL+.net. SQL+.net is a interesting ORM tool. I know, I talked to the founder and CEO recently, and we thought it's a good tool. Check it out. It's for .NET developers if you're trying to create your database layers without writing too much code. Check it out. Both of our sponsors, thank you so much. And everybody else who has donated for the cause, we have hundreds of people, if not thousand, have donated. Either they have donated $5, $10, and several people have bought community sponsorships. So we already donated a lot of money to charity, and rest of the money we're going to continue to do these conferences each month, and we're going to pick different charity every month. So any of you watching, you have a favorite charity that focuses on children or any poor, please contact us, and we are listening here. And with that, I think Simon, you and your team did a great job. You guys are still working hard. Social media team has been active. I see this on every platform. We are kind of blasting all these posts and getting a lot of good reaction. So everybody behind the scenes, great work, great job. We are, as you said, we are halfway there. We're going to continue this tomorrow for 12 more hours.
Yeah, and to join for tomorrow conference, I have dropped the link in the comments. Just click on this link and you will reach to that stream, and then you can go ahead and click that remind notification bell icon, so that when we tomorrow go live, you don't miss us. So that's it. Having said that, let's go ahead and conclude the day 1 of SQL Server Virtual Conference, and we will see you tomorrow at 7:20 a.m. Eastern.
Yeah, and if you last thing is, if you like this conference and you think more people can benefit from it, they can learn from it, please let your friends and coworkers know about this conference. Again, 12 hours tomorrow, free, again from 7 to almost 7 Eastern, a lot of learning. And by the way, these all videos will also be available on C# Corners videos and YouTube channels.
Right. So having said that, thank you so much, and we will see you tomorrow. Bye.
All right. Thank you, everybody. Good night, and see you tomorrow. Bye.
All right.